Hey my dear JEE warriors, welcome to the next day of your 2-week challenge for your refocusing on 99 percentile. All those who feel lost, all those who feel like giving up, this is the series for you because there is no time to give up. It's the time that we actually refocus, realign ourselves. The last few days are there. Let's do all those things which are very crucial, very important for your second attempt. And that's why we are coming here, taking up all the important concepts, all the important PYQs, as well as the tricks while solving the problems. And today we are going to concentrate on magnetic sources, meaning how magnetic field is created, Biot-Savart's law, Ampere's law, their applications, magnetic moment. Then we are going to go to the effects part, which is Lorentz force, right? Forces on charges, forces on current carrying wires, magnetic moment, torque and energy of a magnetic coil, right? So all these things in today's lecture for your second attempt. And before we begin, let me also make a very important announcement. If you want to solve PYQs using a hard copy, then there is no better option than these 3 books of chemistry, physics, mathematics, which is available for all of you in Amazon, which has 46 papers, which amounts to close to 1400 questions. So if you solve around 70 to 80 questions per day, and that is very easy to solve 70 to 80 questions per day, you can complete these 3 books, you will become the master. There is no doubt you will get 99 percentile. And the best part about these books is you can see that it has all the recent papers as well as the detailed solutions, so that you understand how to solve the problem. Just giving the answer key is not important. Seeing the solutions is also going to be important because you might get stuck at many places. They are also organized chapter wise, and you will also see none of the questions have been missed, and it includes all the things, be it MCQs as well as your integer type, right? So make sure you check out the link which is there in the description box below as you are watching this particular video, right? So if you are watching this particular video, right in the description box of this particular video, you will see it right over here, right? The JEE Mains chapter wise PYQs. Just click on this link and you will see the Amazon link out here, right? It is for 1499. You can click on buy now. So that is what the PYQ books are all about. All right, still there is time, make use of it. Let's begin with the class, and I hope everybody is ready. EM waves is also included in today's class. No, EM waves is a separate thing. We'll probably have a separate lecture just on waves, all waves together in one lecture. What say? We'll do that? Yeah, we'll do that. We'll do that, definitely. The schedule was not shared, is it? I'll just share it in case it was not shared. In the crash course, where can we get the remaining chapters, recorded lectures? So Supriya, if you go to the schedule, right, over there only you will see upcoming classes. There is a tab over there which says past classes. Click on past class, you will get the lectures. Okay, it's that simple. All right. Ghost has come to study. Very good. Hello Siva. Hello Yadu. Hello Umesh. Good morning everyone. Great. You are, progressing in this 2-week challenge already. So let's go ahead. Let's go ahead and let's start with the chapter. First of all, remember that whenever you have a stationary charge, it will create electric field. Like you take a proton, it creates electric field. You take an electron, it creates a electric field around it. But you take the charge in motion, like you can see over here, the charge in motion will not only create electric field, but it also creates magnetic field. So a charge in motion creates electric and magnetic field. Remember, the symbol for magnetic field is B. Or charge at rest only will create what? Electric field. So I'll just mention that over here as well. The charge at rest will only create electric field only. What about a magnet? Magnet is nothing but many charges which are rotating, revolving in those teeny mini atoms, and they create their magnetic field. The electric fields are nullified because there are equal amount of positive and negative charges inside the atom, so it gets neutralized as a whole. So bar magnet, or basically any magnet, I can just say a magnet produces this is stationary magnet, static magnet produces magnetic field only. This is stationary magnet. These are the things which you should definitely know. This can come as simple, easy peasy lemon squeezy questions. The unit of magnetic field in SI is Tesla. You also have Gauss, and remember 1 Tesla is 10 to the power 4 Gauss. Gauss is usually used to measure Earth's magnetic field. It is a smaller unit. Otherwise, you generally use Tesla, which is the SI unit. Right? Magnetic field has the same properties just like the electric field, meaning if the magnetic field is going to be drawn, you draw a tangent to it, it will give you the direction of the magnetic field. You draw a tangent, it will give you the direction of the magnetic field at that place. You will never see magnetic field lines crossing each other because that intersection is not allowed, or else there will be 2 tangents at the same point. You will see that if the magnetic fields are concentrated at certain location, like near the poles, the field is strong, and if they are far away, the field is weak. Another important factor, or I would say a property of magnetic field, is it never stops or it never starts anywhere. There is no end to it, there is no start to it, because they are in closed loops. Many people think it starts from north and ends at south, but no, it continues even inside and comes out. So there is no start or end to it like electric field lines. Electric field lines start from positive and end at a negative charge. Everybody remembers all these things? Yep. Yes, Sumati, all the chapters which I will be doing here, and plus I will be giving a list today. Yeah, so do those things which we have also done in the flash series. Whatever we did in the flash series, if you have missed those classes, please watch the flash series classes as well, because that will become a complete package for all of you. Complete package for all of you. Remember that. Okay. Then, to find out the magnetic field, due to a wire which carries current, because at the end of the day, if a charge moving produces magnetic field, then in a wire, what is there? In a wire, what is there? There are charges, protons and electrons. But when you establish current, then the electrons begin to move. So what happens is when you have a wire, right, you have positive charges which are at rest, which is because of the nucleus. You have the negative charges. These negative charges begin to move. And that is the reason why you say that, listen, there is current which is established in the wire, and these electrons which move make magnetic field. Electric field gets cancelled out because of the positive and negative being in equal amounts. It is neutral. So that is the reason why you will basically see magnetic field around it. You will basically see probably magnetic field around it like this. Right? So you will see magnetic field around it. Electric field is absent. Electric field is 0. Magnetic field is non-zero in a current which is flowing in a conductor. Everybody fine till this point? Yep. First concentrate on JEE, then we'll come to VIT, EEE, BITSAT, everything. There is lot of time for that. Yeah. So for the recorded class, Ashwath, please go to the past sessions. There is a tab called as past sessions. Just click on it, you will get it. Number 2, go to my courses. In my courses, you will see the course you are enrolled into. You will get the list of all the chapters, all the sessions which were conducted. So these are the 2 ways. You will not see it in upcoming. You have to go to past session or my courses. In that, click on that course, you will see the list of the sessions, physics, chemistry, maths. So going ahead, Biot-Savart's law gives you the magnetic field at any place due to a wire which is carrying current of a length dl. What is dl? Repeat after me. It is the small element due to which magnetic field is being produced. If there is a big wire, it has many elements. Each element will give a magnetic field. You can integrate and find the total magnetic field at any place. You can always integrate it. You can always integrate it. I hope this is very, very clear. Awesome. Awesome. Great. Everybody with me? Yes. Cool. Let's move on. Let's move on. Next important thing is that this magnetic field depends on where you are, how far you are, what angle you are making, and what is the current in the wire. So it depends on the current, it depends on how much is the length, it also depends on the angle and also where you are from the wire. In fact, the Biot-Savart's law, right, in the simplest form that you want to see, will look like this. Magnetic field is nothing but mu naught divided by 4 pi. You will have I dl r sine theta divided by r cube. That is all it is, right? So this r and this r can cancel out, it will become r square. That is fine. But the point is that you will have dl r sine theta. Sine theta is the theta is the angle between dl, the element due to which you are finding the field, and r is the distance from the element to the point where you are trying to find the magnetic field. Keep this in mind, right? So if you want, yes, you can definitely cancel this r and this will become raised to 2. What is this mu naught by 4 pi? This is your constant, just like your Coulomb's constant. This is the constant which you will have, and the value of it is 10 to the power minus 7 in SI units. And do not forget, the value of mu naught is also called as the permeability. This is called as the permeability of free space, or basically vacuum. Free space or basically vacuum. Yes. Siva, why the electric field is 0? Because there is equal amount of electrons and protons. That's the reason for it. There is equal amount of electrons and protons. It cancels out. So that is why the net field is 0 around that wire. Okay. So if you take a wire which carries current, what is the field outside? Nothing. There is field inside the wire, yes, which makes up the electric current, but outside there is no electric field for a standard constant flowing current. Yes, if the current changes, magnetic field changes, then electric field is produced, but for a constant current, then there is no field outside. Is that very, very clear? Yep. Awesome. Awesome. Let's move on now to the vector form. See, whenever you see dl r sine theta, you should understand that sine means there will be a cross product of them. So therefore, actual formula in vector form is given by mu naught by 4 pi is a constant. You have I dl bar cross r divided by r cube. This is the true vector form of the Biot-Savart's law, which gives you the field at any point due to a wire element dl carrying some current I, making angle theta at a distance r. This is the true vector form. You might get simple, easy peasy questions also in your JEE Main second attempt. Okay, directly length is given, r is given, and all those things. Now, whenever you want to find the direction of the magnetic field, one option that you have is you actually do the cross product, just like you do it in vectors. Oh, dl is here, r is here. You can use your right hand. Everybody can use your right hand. Put your 4 fingers in the direction of dl. Then slowly turn it towards r, because it is dl cross r, a cross b. Move it from a slowly to b. You will see the thumb will go inside. That is why the magnetic field is inside. This is one way of finding out how the magnetic field is oriented. Other better way is that if you have a wire which carries current, again use your right hand, but in a much simpler manner. You hold the wire, grab the wire. Imagine this is the wire which is carrying current. Grab the wire. If the current is going up, ensure your thumb is pointing up. If the current is going down, ensure your thumb is pointing down. If you are holding your pen right now, do it. If the current is passing through the pencil or that pen, imagine upwards, just imagine it to be a wire. Hold your thumb up, or if it is going down, hold your thumb down while you grab the wire. Okay. Then the fingers show you the direction of the magnetic field. So you can see when you grab it up, this is how it will look like. And when you grab it down, this is how it will look like. So the curled fingers show you, those are the concentric circles which are the magnetic field lines around that wire which carries the current. That is the easier approach to find the magnetic field's direction. Is that right? Everybody with me? Very good. Now, using this Biot-Savart's law formula, if you have a long wire or if you have some wire and you want to find the total field due to the entire wire, you take every element and due to every element you see the contribution due to that, and then you integrate it, you will get the total magnetic field. Here whatever magnetic field we got is actually speaking dB, Why did I put dB? Because it is the magnetic field due to a small element, but the total field, remember always the total magnetic field will be nothing but integration of dB. You add up all the magnetic fields, and when you integrate it for a finite wire, this is a finite wire. Finite means it is not infinitely long. There is no end, there is no start, no, nothing like that. There is a start, there is an end to it. It starts here, it ends here. There is some current I in it. You are at a perpendicular distance. Let's say A or R from it. At this point, you want to find the magnetic field. Direction wise, everybody knows. Hold the thumb in the direction of the current. The fingers will curl like this. That means it goes inside here, goes from behind, comes out from here, and then again goes like this and goes inside. Because that's how your fingers will curl. That's how your fingers are going to curl. Right? Direction wise, it is sorted. But magnitude wise, what is the value? It is given by mu naught by 4 pi standard constant. Current is over here. More the current, more the magnetic field. A is the distance. You can also put R. So how much is the perpendicular distance from the wire? Next thing, sine theta 1 plus sine theta 2. Basically, theta 1, theta 2 or phi 1, phi 2 are the angles made by these 2 points at that point. Angle made by these 2 ends of the wire at that point from the perpendicular. So this is the formula. Okay, this is the general formula. You can make it for some special cases like infinitely long wire. If you take an infinitely long wire, then what will happen? The magnetic field will be given by mu naught. Let me show over here. Mu naught by 4 pi. Then you have 1 by A. A over here is basically R. Then sine something plus sine something should come. What will be those sine values? Very, very important. This is an infinitely long wire. It extends till infinity. So if you show a dotted line which goes till infinity here as well as here, because you have to always draw those lines which end at the ends of the wire. So when you show those geometrical constructions for an infinitely long wire, it will open up a lot. These 2 angles, can you not see? It will actually become 90 degree. These 2 angles will actually become 90 degree each. So what will happen, my dear warriors? This will become sine 90. Sine 90 is 1. 1 plus 1 is 2. So this will become mu naught, or this was current, mu naught I divided by 4 pi R, 1 plus 1 which is 2. So it will become mu naught I divided by 2 pi R. This is the formula that you get for an infinitely long wire. Very good. So Diksha, very good. Yes, Ashwat. Awesome, Jashwant. Yep. Very good, Subhrakanti. Yep. Now, for a semi-infinite wire, meaning semi-infinite means the wire is infinity on one side, on other side there is an end to it. The wire starts over here and goes over there. Compare this diagram with this diagram. You will quickly realize this point B has come here. This dotted line will collapse onto this. The angle phi 2 will collapse to 0. Point B comes here. This dotted line collapses onto this line. Phi 2 becomes 0. Phi 1, because this point A will be at infinity, phi 1 will enlarge to become 90 degree. Just visualize this. This phi 1 will become 90 degree, and the other angle, because it is just collapsing over here, the other angle will be 0 degree. So hence in this case the formula will be mu naught by 4 pi current divided by your distance, in this case distance is r, sine of 90 plus sine of 0. Sine 0 is 0, sine 90 is 1, so it will just become mu naught I by 4 pi r. So it will be a little bit less as compared to this. This is higher because 2 is there in the denominator, here 4 is there in the denominator. So obviously due to a semi-infinite wire, it will be exactly half of that of a infinitely long wire. Okay, so that is how you use or apply these particular formulas. Is that clear, my dear warriors? Shall we go ahead to the next one? Okay, let's take some questions now. These were simple Biot-Savart's concepts. Right now, let's apply it to some problems. Coming up on your screen, there is a wire which carries current of 1 ampere flowing in the sides of an equilateral triangle of this much side. Find the magnetic field at the centroid of the triangle. So questions on centroid, hexagon, square, right, triangle, these are all very common questions, my dear students. Let me show you how to generally solve these kind of questions so that you never ever face any difficulty. So first of all, let's draw a triangle. Let's draw a triangle and let's show the current passing through it. Let's show the current passing through it. Let's say it is like this, like this, like this. The current passing is, let's say, I. I want to find the magnetic field at the centroid. I want to find the magnetic field at a centroid. So let me do a small geometrical construction. Let me just drop a perpendicular here. Let me just drop a perpendicular here. And let me just drop a perpendicular here. Okay, so that is the centroid over there. Great. I want to find the magnetic field at that particular point. So in order to find the magnetic field at this particular point, which is the centroid, which I can call it as G, then I need what is the contribution of each side at that point G. If each side contributes some magnetic field, let's say X, each side, because it contributes X, 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 and there are 3 sides, so the total magnetic field at point G will be 3x. Is this point clear in everybody's head? So you first of all see what type of diagram it is. If it is square, you take one side and you find the magnetic field. Because there are 4 sides, multiply x by 4, that is the total magnetic field contribution. If it is hexagon, you find due to one side, x let's say, and you multiply it by 6, so 6x will be the answer. The main problem now is to find that x. For triangle it is 3x, for square it is 4x, for pentagon it will be 5x, for hexagon it will be 6x. Understood till this point? Okay. Now what you should do is basically know what is this distance, and you should also know the angles which are subtended. Let's say for example, I am considering this particular wire. You can clearly see this is that perpendicular distance. I need to know what is this perpendicular distance, let's say from this point to this point G over here. I also need to know what is this angle as well as this angle, because remember for a finite wire you need to know the angle subtended by the ends at the point where you want to find the magnetic field as measured from the perpendicular, right? So what are these angles? That is not that difficult, because this angle and this angle both will be 30 degree each, and because this is 90 degree, this small triangle will make this particular angle as 60 degree. If this is 60, naturally even this is 60 degree. So these two angles are 60 degrees each. Is that much quite clear? Everybody? Very good. So when I want to find the magnetic field due to any one particular side, that will be mu naught into current divided by 4 pi into the distance. Oh, wait a minute, I don't know the distance yet. We'll figure that out. But you will have definitely sine 60 over here plus sine 60 over here. Everybody with me on this? Everybody with me on this? Sine 60 plus sine 60 over here. Very good. Now what? Now what? How to find that distance? That distance you can use some geometry and you can find it out very easily, my dear warriors. If you draw a perpendicular and this is the centroid and this is that particular point P, what is this distance going to be? So let's say this is A, this is B, this is C. Then first of all, what is the side length AP? The side length AP will be AB. This is AB and this is 60 degree. So it is AB's sine 60. AB is sine 60. because this is opposite and this is 90 degrees, so it is AB is the hypotenuse, sine 60. AB, let's say it is small a, sine 60 is basically root 3 by 2. That is what AP is. Now what will GP be? GP will be nothing but how much, guys? GP will be how much? It is 2/3 because it divides it in the ratio of 1:2. It divides it in the ratio of 1:2. So can I just say it is basically 2/3 of your AP. So 2 by 3. AP is nothing but A root 3 divided by 2. So it will just become A by root 3, my dear warriors. It will just become A by root 3. So this A by root 3 is basically centroid to this distance. So just put it over here. So just put A by root 3 over here. Just put A by root 3 over here. You can just now solve this. It's not that difficult. So you can just write it as mu naught I root 3 divided by 4 pi A divided by 4 pi A. Sine 60 is root 3 by 2. Root 3 by 2, but there are two such things. So into 2. Root 3 into root 3 is 3. So it will become mu naught 3I divided by, this will become 4 pi A. This will become 4 pi A. Everybody with me on this? Yep. Now this is due to one side. This is due to one side. When you multiply it by 3, what will you get? You will get the total net magnetic field. You will get the total net magnetic field. Understood? Yes. Yes, you will have to do this in 2 minutes, meaning you will have to practice this problem before only, because you cannot think this in the exam immediately. So if you practice those problems before, you know this is how it is, standard step. This I have to find, this length I have to find. All these things will click like this. That is the reason why you have to practice many problems, and that is the reason why we are coming over here, right? Or else, you know, I can just say, this is theory, this is formula, this is this formula, this is this formula, this by heart. No, that is not the point. The point is to solve the problems, because at this point of time, you know, in JEE what matters the most is solving the problems, right? Yeah. How 2:1 becomes 2 by 3? Okay. See this, tell me this particular property of ratio you should know. Imagine if there is a side which is divided in the ratio of 1:2, meaning if this is x, this is 2x, that means the total will be 3x. The total will be 3x. So if I just talk about this part, isn't this 2/3 of the total? 2/3 of the total, that's all. This is just 2/3 of the total. Got it? Everyone with me? Yeah, you can substitute the values in the end and you will get the answer. So when you substitute, you will get the answer as 4 into 10 to the power minus 5. That's not the point. The point is, how do you solve the problem? How do you use the geometrical principles? That's all. Is that okay, Subrakanti? Yes, cricketer San, is it clear? Sir, triangle is triangle when it is a triangle. No, then how when took triangle as a triangle then? SRP. Please explain me, what do you mean by the triangle is a triangle, triangle is a triangle? Do you understand what you are saying? First of all, please explain me properly. For given current distribution, each infinite length wire produces magnetic field B at the origin, then the resultant magnetic field at the origin is how much? Very interesting question. This can come in your JEE. See, this wire is coming towards you. This wire, dot means it is coming towards you. Cross means this wire is going away from you like this, and this wire is also going away from you like this. 4 wires are there. Imagine you are like this and 2 wires are coming this way and 2 wires are going inside like that. Are you able to understand this? Is that clear? Okay. Very good. Very good. Just one second. Let me just get my water. Just one second. Okay, let's continue. Yes. Sir, last question is I took aero tree. I think I took something else. Oh, I'm so sorry. I think this was, oh, I'm so sorry guys. Let me just do this again. And even this will change. I'm so sorry. Yeah, so sorry. Here I had to take this as 1, this as 2. I took this as 1 and this as 2. My bad. So sorry. Yes. So here this is basically 1, this is 2. So technically this GP was supposed to be 1/3 of AP. I mean, if you go by this particular explanation, this particular part will be 1/3 of the total distance. 1/3 of the total distance. This is what I was supposed to take. This is 1, that is 2. So this part is 1/3 of the total length of AP. So AP is nothing but a root 3 by 2, and you will just get this as a, and this root 3 will cancel, so 2 root 3. A by 2 root 3 is basically this particular part GP. So then substitute this over here, a by 2 root 3, a by 2 root 3 over here, and then whatever value I get over here, this you multiply by 3 to get the net magnetic field, because each side will give the same magnetic field. So you just have to multiply by 3. Yes, yes. Okay. Is that okay? Fine? Yes. Cool, cool. Let's go quickly ahead to the next question coming up on your screen. This is done. Okay. So for a given current distribution, these two wires are coming towards you. These two wires are going inside. Each wire is giving a magnetic field. And that wire's magnetic field is B at this particular point O. So what is the total magnetic field? See, for this wire which is coming towards you, if you hold your thumb towards you, the fingers will curl anti-clockwise. That means at this point, due to this wire, the magnetic field will be like this. The magnetic field will be upwards. Just check this out. So due to this particular wire, the magnetic field is upwards. Is that part clear? Then due to this particular wire, if you again show the magnetic field lines which will be anti-clockwise, so if you draw a circle like this, you can see the magnetic field is going towards the right side. So the magnetic field will be in this particular direction. Till this point, everything is clear? Okay. Next, let's take this wire. This wire, the current is going inside. So hold the thumb like this. You will see the fingers curling clockwise. Fingers are curling clockwise. That means like this. The magnetic field is like this. Magnetic field is basically like this. So at this point, the magnetic field due to that wire will be in this direction. And the last one, due to this particular wire, again the current is going inside. Hold the thumb inside. The fingers will curl in the clockwise direction. That means like this. So as you reach here, the magnetic field should be in this direction towards your right side. So again, I will put one more arrow mark over here. Each of them is B. Each of them, this is B, this is B, this is B, this is B. So these two together will make it 2B. These two together will again make it 2B. So both these 2B's are perpendicular to each other. So my dear warriors, what will happen? What will happen to the net magnetic field? The net magnetic field will be 2B times of root 2. How did I get that? You can just use Pythagoras. 2B square plus 2B square. The whole thing under the root is the net magnetic field. So this will make it 2B times of root 2. 2B times of root 2 is there as option number C. Got it, my dear warriors? Understood how to solve this particular question? Very good. So here directions play a very, very important and crucial role. If you miss with the directions, that's it, gone. If you miss the directions, then you're gone. You might probably get the answer as 0 also if you end up cancelling it. Okay, some people might cancel those things and you might get option D, which is wrong. Be little careful there. Moving on to the next question on your screen. There are two long wires carrying currents and they are placed parallel to each other at some distance of 8 centimeters between them. The magnitude of the magnetic field at the midpoint of the two conductors due to the current flowing is this much. The equal current flowing in the two conductors is. Okay. First, let me show the wires. One wire is here, another wire is here, and there is some separation between them. Let's say, the separation between them, which is given to be 8 centimeters like this. Now, imagine one of the wire is carrying current like this. One of the wire is carrying current like this. Due to that, what will happen? If you hold your thumb in that direction, the fingers of your right hand will curl in this particular sense. So, as you reach the midpoint, the magnetic field at the midpoint due to that wire should be downwards. Should be downwards. Everybody with me? The magnetic field will be downwards due to this particular wire. Because the other wire should also add to the magnetic field. Reason, there is clear mentioning of the word that there is 300 microtesla of magnetic field. There is no 0 Tesla, it's 300 microtesla. So obviously the other wire can't cancel it out, it has to add it. It has to add it. That means the other wire's contribution should also be B1 and the magnetic field should be in this particular direction. So if you curl your fingers in this anti-clockwise sense, you will see the thumb coming this way. Curl your fingers like this, you will see the fingers coming this way. That means the current should be like this. That means the current should be like this. Everybody with me? Understanding till this point? This means the current will be in the opposite direction. So same direction gone, same direction gone. Even this same direction is gone. There is only one option which says opposite direction. There is only one option which says opposite direction, which means the correct answer has to be B. You don't even have to solve it. And yes, this was a JEE Mains 2022 question. This is a massive, amazing trick where we didn't even calculate. But imagine there were two options which said opposite. Then obviously you have to sit and calculate. There is no other way to do that. So how to do that kind of problem? Well, here is the thing. We know from here to here, this distance will be 4 centimeters. Same thing from here to here, this particular distance will also be 4 centimeters. And we know one more thing, 2 times of B1 is 300 micro, which is 10 to the power minus 6 Tesla. Because B1 plus B1 is the total magnetic field, which is 300. How much is the magnetic field due to any one wire? How much is the magnetic field due to any one wire? Use this formula, mu naught by 4 pi into current divided by the distance. Distance is 4 centimeter. So 4 into 10 to the power minus 2. But into 2 comes, so actually for an infinitely long wire, this 4 pi just becomes 2 pi. This 4 pi just becomes 2 pi. If you remember, this was the formula for an infinitely long wire. Mu naught I by 2 pi r. Infinitely long wire. So just I'm using that same formula right over here. Mu naught I divided by 2 pi r. R is 4 centimeters. So this is basically 300 into 10 to the power minus 6. Solve this, you should get the current as 30 amperes. Is that very, very clear, my dear warriors? You should get the current as 30 amperes. Cool. Shall we go ahead? Yep. Awesome, awesome, awesome. Very good, very good, very good. Keep it up. Let's move on. Let's move on to the next one. Right. Let's go to the magnetic field due to a circular loop carrying current. Now, a long wire produces magnetic field around it given by the formulas I told you. If you take a wire in the form of a current carrying loop like this, then the magnetic field formula for the center is given by mu naught I by 2r. There is no pi over here. That is a major difference. Many people get confused. Sir, when there is pi, when there is no pi? I'll tell you. Usually, pi is associated for circle. Pi, where did that pi come from? From circle only, right? So, pi is not there in the formula for the circle. It is exactly opposite. For a long wire, there is no need of pi. So over there you will have pi. You can think of it like this. Okay. So it's exactly opposite of where you think pi should be there. Circular loop, pi is not there, although pi is derived from a circle. For a long wire, pi was not even related, but over there you have pi. Is that okay? So that is the major difference. Other than that, if you make n windings out of it, n number of windings out of it, then the magnetic field will become n times of this magnetic field. That is as simple as that. Another variation which you should know, I'll come to the direction part also in a bit, is if it's not a complete loop, if it is a part, if it's an arc of the circle, it's a part of the circle, then each arc will contribute some magnetic field. So the magnetic field due to the arc will be, you take the total magnetic field due to the circle and multiplied by the fraction of the angle subtended at the center. See, think about it this way. Imagine this was an entire circle and at this center it produced a magnetic field B0. Now, if you take a small arc like this and at this point it is going to produce some magnetic field, the magnetic field will be how much? It will be B0, but you will multiply it by a fraction. What is that fraction going to be? Observe. If this angle is theta, so you will multiply it by theta by 2 pi. Why? Because imagine theta is 60 degree or basically pi by 3. So pi by 3 is 1/6 of the entire circle. So how much fraction of the entire circle are we talking about? Theta by 2 pi. That is why this number will come. That is why this particular number will come. This is the fraction. This is the fraction of the circle. Fraction of the entire circle. This is the fraction of the circle which you are basically considering. Is this very, very clear? Is this very, very clear? So if this is theta, this will be theta by 2 pi. If this is alpha, it will be alpha by 2 pi. One and the same thing. So what is B0? B0 is the magnetic field due to entire loop, which is mu naught I by 2r. Mu naught I by 2r. Standard. No pi over there. Now, if you take a ring or a coil, but you are not at the center, you are at some distance from it, then the magnetic field has a slightly weird looking formula which you have already seen in electrostatics. The magnetic field formula is mu naught I into, basically you have r square divided by 2 into r square plus x square raised to 3 by 2. This is the formula when you are on the axis of it. In these problems you are at the center. But imagine you are away from the center by some distance. That means you are on the axis of the coil. Then the formula comes out to be mu naught I r square by 2 r square plus x square raised to 3 by 2. A special case of this is if x is equal to 0, then you are at the center. You are at the center. You can try putting out x is 0 in this formula. Mu naught I r square by 2 r square plus 0 raised to 3 by 2, which comes out as mu naught I r square by 2. R square raised to 3 by 2 is basically r cube. R square cancels and you will get it as mu naught I by 2r. This is exactly the formula which you need at the center. So this is the godfather formula. This is like the god formula which includes this special case also. Okay, so when you are on the axis, you are going to use this particular formula. Keep this in mind. These kind of questions are also very common. Now let's go to the direction part of it. It's again very straightforward. Imagine you have a loop which carries current like this. Basically like this. What you should do is curl your fingers of your right hand. Which hand? Right hand. You have 4 fingers, so I am showing 4 fingers like this. This is your 4 fingers, I hope. Okay, this is the 4 fingers of your right hand. You will see if it points in the direction of the current, then the magnetic field lines then the magnetic field lines which are being generated is given by the direction of the thumb. Is given by the direction of the thumb. Is that very, very clear? So this is how you will visualize this. Okay, this is your right hand, guys. Okay, this is your right hand. I hope this is very clear. I have drawn a beautiful right hand. So this is how your magnetic field is created. In fact, it is actually speaking like this. It has to be circular loops, remember. It cannot start or end anywhere. It has to be continuous. It has to be continuous. So this is how the magnetic field lines actually end up looking. Okay, this is how the magnetic field lines end up looking due to a wire loop carrying current. Okay, this is wire loop carrying current, and this is how the magnetic field lines are. Beautiful diagram. Yep. Yes, great. All right. Preeta, yes, if you are a NEET aspirant, you too can watch this video. I mean, for the sake of it. I mean, these problems will be slightly of a higher level than NEET, definitely. In fact, these are also going to include JEE PYQs mainly. So, if you want to push yourself, you can watch. Okay, so this is the same diagram which I have shown. You can see the wire is carrying current like this, and you can see the magnetic field lines are going exactly the way I showed it to you right over here. Okay, it's just that the diagram has been tilted a little bit, that's all. Otherwise, these things are as it is. All right, so I think it's a good time that we start solving some questions. Okay, and the graph of the magnetic field looks something like this when you are on the axis of a coil. So when you are at the center versus when you go away from it, how does the graph look like? This is also very interesting. It looks something like this. It is maximum at the center, and when you go very far away, either this side or that side, the answer tends to 0. So that is all that you need to remember. One more concept which you should also know is that when you are on a long wire and you are on the axis of that long wire, not a loop, I'm talking about just a straight wire. This is just a straight wire which is carrying some current. Then at this point, the magnetic field is 0. Also at this point, the magnetic field is 0, basically on the axis of the wire. Yes, here the magnetic field is not 0, or even here the magnetic field is not 0, but on the axis, remember, the magnetic field is going to be 0. Let's start solving some questions. There is a wire which carries current of 14 amperes bent into an arc, some radius as shown. The magnetic field produced by the current at the center O of the arc is how much? The center O of the arc is how much? That is the question. What will you do? You'll first realize that there are 3 parts of the same geometry. One is this straight wire, one is this curved arc, and then there is another straight wire. Each part will contribute to the magnetic field at point O, and let's find out how much is the contribution. First of all, you will realize that because of this straight wire, if you try to calculate the magnetic field at point O, there will be no contribution at all because of the thing which I just told you over here, the concept, right? Away from the wire, there is magnetic field. On the wire, on the axis of it, then there is no magnetic field. Yes or no? So that is the reason why this part will have no contribution. Even this part will have no contribution because you are on the axis of the wire. So the straight wires contribution, is how much? 0 on the axis. So who will contribute? I think only this semicircular arc. The current is going like this. Curl your fingers. Clockwise, the thumb goes in. So the magnetic field will be inwards. So I can just say that the net magnetic field is only due to the semicircular wire, nothing else. And whatever field is being produced by the semicircle will be half of the entire loop had it been there. Correct? If one more semicircle was there below, it will make it a loop. So 2 halves make a circle. two semicircles make a circle. So one semicircle will be half the magnetic field of the entire loop. So it will be half the magnetic field of an entire loop, and this will be nothing but half into mu naught I by 2R. So this will be just mu naught I by 4R. You know the current, you know the R, you know the value of mu naught. You can substitute and you will get the answer as 2. This is how you're going to do it. This is how you're going to do it. Is that okay, my dear warriors? Understood? Yes, perfecto, perfecto. So these kind of questions will come in the JEE examination. If you open up the previous year papers, if you open up all the books that you have for previous years, if you see the questions, you will see these pattern of questions. These are very, very common standard pattern only which I am solving. I am not solving anything way beyond JEE Mains which is not going to come. These are all high probability. When you see the paper in April attempt, you will remember me. Moving on to the next one coming up on your screen. This is also a very interesting question. This has also come in the previous years. A long wire is bent as shown. If the radius of the loop, a semicircular part, is A, then find the magnetic induction at point C. Okay. Now what is interesting about this problem is in 3 dimension. You can see x-axis, z-axis, y-axis, and the wires are in the y-x plane, horizontal plane, and in the zy plane, which is vertical, you have the loop. So first of all, decide the directions, then we will proceed ahead. So say for example, if I take only this semicircular loop, the current is going clockwise. Hold your curled fingers in the clockwise direction. You will see the thumb. You will see the thumb going in. You will see the thumb going in. So that means the magnetic field is along minus x. The magnetic field is basically along minus x. That is the one thing. Let's say I call it as B1. Next, due to these straight wires, how is the magnetic field going to look like? So first of all, due to this straight wire, hold your thumb in the direction of the current. The curled fingers, hold the thumb in the direction of the current. The curled fingers will go like this, will go like this. You can see that it's going like this. So it is coming like this. So at this point also it will be going down only. So the magnetic field, right, due to that is just going to go down. The magnetic field is just going to go down due to that. Let's say I call it B2. Due to this wire, again, if you try to find how much is the magnetic field, what is the direction of it? Well, hold the thumb in the direction of the current. The curled fingers will be like this. That means the magnetic field will be like this. That means again the magnetic field will be down only. So it will be B2 and B2. So B2 into 2. B2 into 2. Understood why I am saying B2 into 2? Because both the magnetic fields will just add up over here. Right? So B1 is here. B2 2 times is down. In fact, they are both perpendicular to each other. Did you realize it? Did you realize they are both perpendicular to each other in the ZX plane? In the ZX plane. Just try to visualize that. So the resultant magnetic field will be actually like this. Will actually be like this. See if you are able to visualize this. This is how the net magnetic field will be in the 3 dimension. You have to visualize this. Very good. So how much is B1? How much is B2? Let's quickly write it down. B1 is due to the semicircle. So it will be half of the magnetic field due to the entire loop. So it will be half of mu naught I by, is the radius given? Yes. By 2 into A. So it will be mu naught into I by 4A. That is what it is going to be. Next, due to this wire, any one wire, the magnetic field is B2. This is, remember, the magnetic field due to a semi-infinite wire. The magnetic field due to a semi-infinite wire, I gave you the formula just some time back. In case you are joining in late or you have forgotten, let me show that to you right over here. Semi-infinite wire, it starts at a point and goes till one side till infinity. It is mu naught I by 4 pi r. I just gave it to you. So just use that. So just use that over here. Where is it? Yes. So it is nothing but mu naught I by 4 pi. And what is the distance? The distance is A. So 4 pi A. Correct. So if I multiply B2 2 times, it will become 2 times of this. So what will be the net magnetic field? What will be the net magnetic field? It will be root of something square plus something square. Something is B1. So B1 is nothing but mu naught I by 4a this square plus what will I have? I will have this one, this guy. So 2 times of B2, 2 times of B2, which is mu naught I by 4 pi a whole square. This is what the final expression will be. You can take mu naught outside, 4a also you can take outside, everything, current also you can take outside, pi will remain, I think, right? You do the math and you will get the final answer. Understood, my dear warriors, how to do this particular question? Isn't it very, very interesting? Isn't it very, very interesting? So this is how you're going to solve it. When you solve it, finally, this is what you are going to get. Mu naught I by 4 pi a, pi square plus 4. All right. So that is the final answer that you will get. Did you see some new thing? Did you see some new problem? Did you see some creative way of visualizing these things? Always, whenever there is a wire which is being bent with a straight wire, semicircle, quarter circle, divide it into parts. Find each part's contribution separately, just like I did here, or even I did over here. Some parts may not contribute at all. Some parts may contribute, and their contributions might be different in different directions. So finding directions becomes very important, and then you use final vector addition only to basically find where the resultant is going to be. Okay, sometimes it might add, sometimes it might cancel, sometimes it might be perpendicular, sometimes it could be at 60 degree, who knows? Yeah. So that book will include out of portion also. Cricketer, whatever has been asked in JEE, only that is there. Okay, there is no point of going out of portion. I mean, whatever is there in the JEE syllabus, only that JEE syllabus and JEE PYQs are going to be there in this book. Yeah, there is nothing like out of syllabus. What do you mean by out of syllabus? It's proper JEE book, that's all. Yeah. Now, these 3 variations are also very important because these 3 variations have come in multiple shifts, multiple years. Calculate the field at the center for semicircle, this one, and this one. This one we just did. This part A, we just did it over here, right? This part has been just done over here. So I will just say this done in previous slide. Done in the previous slide, right? So this was just done where these 2 parts did not contribute. This part contributed in the magnetic field. This is another interesting problem. You can see the wire is straight, curved, and again straight, and you have to find the magnetic field here. Again, quickly let's think. Let's not solve the complete thing. Let's just come to the steps part, the logical part, the algorithm part. What will be the magnetic field at point O? So divide the entire wire into parts which can be easily solvable. So I take one part like this, the semicircle. Let's say if I curl my fingers in the direction of the current, the magnetic field, my thumb is coming out. So the magnetic field will come out. So B1, which is going to come out, will be mu naught I by 2R multiplied by half. This half has come because it is a semicircle. That's all. Because it is a semicircle. And the magnetic field is coming towards you. Then let's take this part. Here the current is going like this. The current is going basically like this. So hold your thumb in the direction of the current. Magnetic field will go in, go below, and come out from point O. It will go like this and go like that. See how my fingers are curling. How my fingers are curling. It is again coming towards me only. It is again coming towards me only. So the magnetic field B2 is also coming towards me. So it will be mu naught I by 4 pi R, because this is a semi-infinite wire. For semi-infinite wire, it is 4 pi R. Why is it semi-infinite? It starts here and goes till infinity. Over here also, you can say the same thing, right? So if it is continuing till infinity, right, this is also semi-infinite wire. You take the direction of the current in this particular manner. You take the direction of the current in this particular manner. The current goes up and comes towards you. The current sorry, the magnetic field goes up and then comes towards you. Again, it is outwards. So this magnetic field will come 2 times. This magnetic field will come 2 times because there are 2 wires. There are 2 wires. All these fields are coming towards you. That means the net magnetic field, that means the net magnetic field will be just simple addition of these two. Will be just simple addition of these two. So mu naught I by 4r plus you multiply this 2 times will come. So there will be mu naught I by 4 pi r multiplied by 2. This 2 has come because there are 2 wires like this. So you just add them and you get the answer. Is that clear? Oh, that reduced syllabus? Yes, obviously the reduced syllabus is not taken care of because, you know, what if next year the syllabus increases? You know, some people will buy this book and hand it over to their juniors. All those things might happen. So, yep, all the PYQs are there. So we have not reduced the syllabus and given it because this book can be utilized by your younger brother or some friend of yours or somebody who is going to use this later on, right? All those things can happen. Okay, we wanted to give everything, and sometimes it happens that you are preparing for multiple exams. In maybe another exam, the syllabus is not reduced, right? Some local CET, they have not reduced the syllabus. So you can use this book for other exams also. So that is the reason why we have not kept the reduced syllabus. Okay. What about this? This question is just like the previous one, just that this semicircle has come to this side. So what will be the difference, my dear warriors? See, this part of the wire, this particular part of the wire will still give you the magnetic field this way. Even this part of the wire which is carrying current like this will again give you the magnetic field this way. So B2 will be there 2 times towards you due to the semi-infinite wire that is still going to be there. But due to this particular wire, see how the magnetic field is going to be. Curl your fingers clockwise. You will see the thumb going in. So the magnetic field will be inwards. So the magnetic field will be basically inwards due to the semicircular part. So when you calculate the net magnetic field, you will have to subtract the two. So it will be the, I would say the positive difference. Take it as the positive difference of the field. The positive difference of the fields. You take the bigger one minus the smaller one. Here there was plus, right? So you put a minus sign and put a mod value. That's all. Is that clear, my dear warriors? Understood how to solve this question? Okay. Let me know if you are seeing a lot of varieties. Let me know if you are understanding. Let me know if you are learning. Give me a thumbs up. And if you have not yet smashed the like button, do that right away, right now. I'm waiting for all of you. Can I give the list of chapters which is, yes, I will definitely do that. Mani Chinish. Definitely Jaswant. Definitely. Yep. Sir, what's the max time to solve a question in the exam? Supriya, the max time to solve a question in the exam can be 5 minutes. That's okay because there will be few questions which you can solve within 15 to 20 seconds, and most likely it will happen in chemistry and very few questions in physics also that you can solve it the moment you see it. Either you know it or you don't know it. Like especially inorganic, and even the physical paper which came was very simple this time. Some of the organic questions were tricky, but few of them were, again, directly if you know it, you know the product, you know the reagent, you know the mechanism, you know it, right? Physics also, few questions were actually directly straightforward. Within 30 seconds, you could solve it. So every question that you save 30 seconds, right? If you just, solve 4 questions with 30 seconds less, you have already saved 2 minutes over there. So you can spend those extra 2 minutes in the next question. So that is how you'll have to balance it out. And another thing is you don't require to solve the entire paper. So if there are 25 questions so 75 questions in altogether, even if you solve 60 questions, that's a big deal, right? Even if you solve 50 questions, right? So 50 into 4, it comes out to 200 marks. You will get 200 marks, which is most likely going to fetch you 99 percentile. So that is the reason why I said that you can save up time in some questions. You can also assume that you will not solve all the questions. So you might take 5 minutes in some questions, remember that, but not all. That will be very few in number. All right, moving on to the next one. A long wire which carries some current is bent into a circle of 1 turn and the magnetic field at the center of the coil is B. It is then bent into a loop of n turns. The magnetic field at the center of the coil will be how much? First, that wire is bent into 1 turn, then it is bent into n turns. The magnetic field will be how much times? So what you do is, just imagine you take a wire. This is a wire of length L. This is a wire of length L. And in general, you make it into a coil of n number of turns. Make it into a coil of n number of turns. I can tell you one thing. Each circle's perimeter or the circumference multiplied by n should be the length of that particular wire, because if you open up the wire, you should get open up the loop, you should get back the wire. So the circumference will be nothing but 2 pi small r multiplied by 2 pi small r multiplied by, oops, what just happened? Multiplied by n, multiplied by n is equal to the length of the wire, which is basically L. So from this, I will get the radius as L divided by 2 pi n. L divided by 2 pi n. I need it for my calculation. I'll tell you how. When there is only one turn, if n is equal to 1, the magnetic field is B, and that magnetic field is given by mu naught I by 2 r, and r over here is nothing but L by 2 pi n. N is also 1. So this will become mu naught I divided by 2 L. Actually that 2 will cancel and you will just get L, and that pi will go on the top. Mu naught I pi by L. 2 has cancelled, pi has gone on the top. This is for n is equal to 1. If for n number of turns, then the magnetic field B prime will be mu naught I, you multiplied by n. Why multiply by n? Because there are n turns. Each turn will give you some magnetic field. So you multiply by n to get the total magnetic field, divided by 2 r. R over there will be 2 times L divided by 2 pi n. So let's see what happens over here. This 2 will get cancelled. You will get mu naught I. This n into n will become n square, and even that pi is there upon basically L. Now closely observe this. Mu naught I pi by L. Mu naught I pi by L is technically the old magnetic field, which is B, and what is remaining is just n square. So the new magnetic field B prime is Bn square. Bn square, that is basically option B, option number B. Many people think it will be option A, and that is why many people got negative marks. They think, sir, one coil will give B, another coil will give 2B. If you take n coils, it will take NB. Do not forget, the wire length is the same, so even the radius is changing. So when the radius is going to change, you have to account for the change of the radius as well. And many people made a mistake in this problem in the actual exam. They have lost marks. Okay, shall we go ahead to the next question, my dear warriors? Here comes the next question on your screen now. The ratio of the field at the center of a current carrying coil of radius r to the magnetic field at a distance r from the center of the coil is root x is to 1, the value of x, numerical type JEE 2023. Okay, so first things first, let's draw. This is the coil which carries some current. Let's say the current is basically I, and you are on the axis of it, and on the axis you are at a distance of r. It is also mentioned to you the radius of the coil is also r. Question is, if you find the magnetic field at a distance r from the center, right, and you take the ratio with the magnetic field at the center, what is that ratio going to be? That is what the question is. First of all, what is the magnetic field at this point? What is the magnetic field at this point? So the magnetic field at that point, let's say I call it B1, is mu naught I by 2r. This is just at the center. This is just at the center. If you try to find the magnetic field over here, this is, let's say, B2. This will be mu naught I. Remember, r square is there and 2 is there. R square plus x square. X over here is r. X over here is r. R square plus x square. X is the distance from the center. Whole raised to 3 by 2. This is on the axis. This is on the axis. So what will happen? Mu naught I r square divided by 2. R square plus r square, 2r square. So it will become 2 raised to 3 by 2 into r square raised to 3 by 2. I'm just separating them out because it is easy to handle. R square raised to 3 by 2 is r cube. R square and r cube will cancel. So you will get mu naught I by 2. 2 is there over here. And r cube is there, r square is there. Only one r will remain. And this will become 2 raised to 3 by 2. 2 raised to 3 by 2. 2 raised to 3 by 2 is basically 2 cubes half, raised to power half. 2 cube is 8. Root of 8 is 2 root 2. So this will become mu naught I by 2 r. And here I will have 2 root 2 over here. 2 root 2 over here. What is this? Mu naught I by 2r. Mu naught I by 2r is B1. So technically this is nothing but your B1 value. And here what you have is 1 by 2 root 2. 1 by 2 root 2. Now let's take the ratio. Basically whatever we got over here was B2. So if I want B1 by B2, if I want B1 divided by your B2 value, B1, I take this B2, whatever this was, remember this was B2. This B2, if I take it below, 2 root 2 will go on the top. 2 root 2 will go on the top. So this will be 2 root 2 by 1. This will be 2 root 2 by 1, which is also root of 8 by 1. So the question was, what is the ratio going to be? It is root x is to 1. So that root of x, that x will be 8. That x will be 8 answer. Yes, that is the correct one. So the physics ended here. After this was pure algebra, right? Roots and all those things. Yep. This was a standard question. This has been also asked in this year. How many of you remember even in JEE Mains 2024 this was asked? 2023 also it was asked. Even before that also this was an important problem. This model of axis on the loop. What is the field? What is the ratio? This is a standard question. Moving on to the next one coming up on your screen. Okay, and there we go to Ampere's loop law. Ampere's loop law. Ampere's loop law is all about finding the magnetic field due to wires carrying current without having to actually integrate, right? And whenever you have multiple wires carrying current, let's say this is carrying like this, 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 this is, let's say, carrying like this. Each wire might produce some magnetic field. Let's say at this particular point, the magnetic field produced is, let's say, B1. What you do is, let's say you are going along a path. You have chosen an hypothetical imaginary path and you go over here. At this point, maybe the magnetic field is this much. Then you go to the new point. All right, maybe over here, and you find the magnetic field. Maybe the magnetic field at this point is just this much. Then you go to the new point, okay, and then you find the magnetic field at that particular point. Maybe it is just this much. I'm just showing some example. So like that, you keep doing that, but ensure that you come back to the original point. At every point, there could be some magnetic field. At every point, there could be some magnetic field which is there, like this, maybe like this. I'm just showing some random examples, like this, like this, like this, like this, like this. At every point, some magnetic field will be there. What you do is take the magnetic field at that point and take the dot product with the small distance that you have traveled, that means it is dl, and you sum them up. Sum them up means you are integrating, but because you are coming back to the original point, because this is a Amperian loop, This is called as an Amperian loop. Amperian loop means closed path. You are coming back to the same point altogether. So that is why you will put a cyclic integral. You will put a cyclic integral over here. Is that clear? This value ends up being whatever current is passing within that loop. What is that current which is passing within that loop? If you count, actually this is not inside, this is not inside. Only these three currents are basically your enclosed currents. Correct? So that will be equal to mu naught into I enclosed. The total current enclosed into the permeability is going to be the total value of this. This is called as the Ampere's loop law. B dot dl cyclic integral is mu naught sum of the currents. Is that right, everybody? Very good. Now many people do not know which one to take positive, which one to take negative. Some people by heart, if it is going in, then it is negative. If it is coming out, it is positive. That's not true. For this diagram, it happens like that. But for every diagram, it might change. How to decide the direction? How to decide the sign rather? See, to decide the sign, what you should do? You are traveling in this Amperian loop. So you are going, let's say, like this. You're going, let's say, like this. You're going like this, like this, like this, like this. You are going like this. The direction in which you traveled, make it your curled fingers. Make it your curled fingers. 1, 2, 3, 4 fingers, right? Perfect. Curled fingers. And then your thumb will automatically point in a certain direction. That is the positive direction of the current. Automatically the other direction will become negative. So if you see over here, this current is going in the direction of the thumb. So hence this is a positive current. This current is going down, this current is going up again in the direction of the thumb. So this is also positive current. Whereas this is going to be negative current because it is going against the direction of the thumb. Understood how to count which current is positive and which current is negative, my dear warriors? Yep, very good. Awesome. Great. So to go from 90 percentile to 99 percentile, I would say, see, if you are getting 90 percentile, I'm assuming your marks are close to 100, 120, and you are now planning to go to 180 to 210 range. That is what you are trying to do, basically increasing by 100 marks. So you first of all distribute how you are going to, increase the marks in each subject. Maybe already in maths, you have already tried your best, you know that it is not going to increase, or maybe in maths you can increase. So let's say you distribute out of 100 marks, maybe 15 marks or 16 marks I will increase in maths. Maybe 30 or 40 marks I will increase in physics. Maybe another 50 marks I will increase in chemistry. You distribute those marks first of all. You make a plan according to that. Let's say if I want to increase 15 marks in mathematics, which chapters I can study more to increase those marks? Then if I want to increase 50 marks in chemistry, which are the chapters which I can do easily? If I want to increase 30 marks or 40 marks in physics, which are those chapters which I need to study, which I have not studied before? Okay. Then you might say that, okay, if I study these particular chapters in physics, I might increase the marks by 20 or 25, but not 30 marks or 35 marks. Then you understand, okay, for those remaining 10 marks, what else can I do? Maybe I'm doing some silly mistakes in the paper. Okay, avoid those silly mistakes. See where you are making conceptual errors. Do those topics even more properly. Read the questions properly. And see if you can change the paper attempting strategy. Sometimes if you change the order of the events, change the order of solving and choose the questions wisely. And if you are super duper confident in the first 5-10 minutes, then the confidence level builds up in the rest of the paper. So that way you will be able to solve more questions in a better manner. That will push up your score by more 20-30 marks. So that is what you need to do. I hope I have answered your question. Okay, cool. Moving on to the application part of your Ampere's loop law. moving on to the Ampere's application part, right? So there are two major applications and then there are two sub applications also, you will see. One is for a long wire, one is for the solenoid and toroid kind of geometries. The long wire also has two sub cases. One is hollow cylinder and the next one is a solid cylinder. Hollow cylinder means the current is flowing on the walls of the cylinder like this. The current is not going like this. No. The current is going on the walls of the cylinder in this particular fashion. Try to visualize this. Current is going like this, like this, like this, like this, like this, like this, everywhere. So that is how the current is going. So in such a wire which has a hollow part in it and the current is along the axis in the walls of the cylinder, you will see if you are standing anywhere inside the cylinder and if you by chance end up using Ampere's loop law, the current enclosed anywhere will be zero. The current enclosed anywhere will be zero, isn't that right? So what does that mean? Anywhere inside you will get no magnetic field. Anywhere inside you will not get magnetic field, because if you draw any Amperian loop path like this, B dot dl, B dot dl, B dot dl is equal to mu naught I enclosed. I enclosed is only 0. 0 into mu naught is going to be 0. So cyclic integral B dot dl is 0. That means B is 0. So you will not get only any magnetic field inside. But if you take a loop outside, then the total enclosed current will be the I value. So this behaves like a wire. This behaves like a long wire. So the formula should also be like a wire only. So that is why you will see inside it is 0, outside it is like a long wire. And the graph will be like this: 0, sharp rise over here, and then inversely proportional. This particular region that you see over here, is a hyperbola. Because it is inversely proportional to R. So this is a hyperbola. Does this graph remind you of something? I think it should bring back some memories of electric field due to a shell which is hollow. This is a hollow cylinder, there it was hollow shell, hollow sphere. So the field in a hollow sphere is 0 inside, suddenly jumps and behaves like a point charge. Same way, it is 0 inside, jumps and behaves like a long wire. That's the only difference. If you remember it like that, it becomes easier to remember, easier to recollect in the examination hall. Is that okay? Right. Great. All right. NIT 3G CSE SRP, I doubt, bacha. 180, I think it is definitely not going to be easy, because NIT 3G CSE is like most sought after, highly demanding branch, and that too if you have category, and that too maybe home state, maybe there could be chances. That too you need to see the past year data, but it is on high demand. NIT Trichy, NIT Surathkal, Warangal, highly demanded. Then you get Nagpur, and then Calicut, and then Allahabad, and all these other NITs, Surat. So then you will see the ranks go slightly lower, and then for other NITs even lower. But computer science everywhere closes very high, irrespective of the NIT, because they know that doesn't matter which college you are from, at the end of the day so much. Little bit, yes, it will matter, but once you are from computer science, the job demand, you can go for higher studies, you can do some specializations also, and once you are a computer science engineer, you can go into any company because placements are really good. So that is how it is. Okay. But if you have a solid cylinder, this is like your solid sphere situation in electrostatics, where if you are inside, the field is not 0. In fact, it goes up, reaches the maximum value on the surface, and then behaves like a point charge. So it goes down like a curve. Same thing happens for a solid sphere, solid cylinder also. It goes up and it comes down like this. Inside it is proportional to R, that's why a straight line. Outside it is inversely proportional to R, so it is a hyperbola. So how to remember the formula is this graph, and resembling it to, or trying to relate it to a solid sphere in electrostatics. Okay, solid sphere in electrostatics. So you will see inside it is proportional to R, so mu naught I R by 2 pi R square, and outside same formula as a long wire. It is mu naught I by 2 pi R. So here it is, I would say, just like a wire, just like a wire, just like over here as well. I will say just like a wire, just like a wire formula, infinitely long wire formula. Is that okay? Shall we do some questions based on this? Here comes the question. A long straight wire, radius A, carries a current distributed uniformly on the cross section. That means it's a solid cylinder wire, complete distribution, just like in this situation. You can see the current is distributed throughout that solid cylinder. It's not going only on the walls, it's going everywhere. Remember, in the hollow one, it only goes on the outer walls. It's the solid cylinder where the current flows even inside as well as the walls. So this is a solid cylindrical case through the cross section. Ratio of the field due to the wire at a distance A by 3 and 2A respectively is how much? That's the question. Okay, come on my dear warriors, what will you do? You will definitely use two different formulas. The first formula will be for inside, second formula will be for outside, because if this is your solid cylinder of radius A, one of the points is at A by 3. A by 3 is over here. A by 3 is over here. And your 2A is right over here. 2A is right over here. The ratio of the magnetic fields at a distance of A by 3 and 2A respectively from the axis of the wire. Yes. So at this particular point, the magnetic field inside will be mu naught I. Remember this formula we have to use, mu naught I small r by 2 pi r square. Small r is the distance from the axis. So it is A by 3 by 2 pi r square. R over here is A. So A square. So it will become mu naught I. 3 into 2 is 6. So 6 pi A. That is what the magnetic field will be. When you go outside, then remember it just behaves like a normal wire. So mu naught I by 2 pi r. R is just the distance. So mu naught I by 2 pi r. R is nothing but 2A. So this will become mu naught I by 2 to the 4. So 4 pi A. All you need to do now is just take the difference of it. So B, a ratio of it, sorry. So the ratio of the magnetic fields is us. So B in by B out will be this by this. Mu naught, I, A, pi cancels. So I'll have 1 by 6 by 1 by 4. So it will be 4 by 6, which is 2 by 3. So 2 by 3 should be the answer which was asked in JEE 2020. Is that okay, my dear warriors? Yes. SRP, I think I have just answered. SRP, you can do one thing. There is a college prediction tool which is there by Vedantu. I think you can just check some old videos, 1 month back videos or something. In that college prediction tool is there. Over there you will understand. Okay, you can put your home state, you can put the branch, or rather you can put your percentile. You will get the list of the colleges and the branches also. Everything you get. Just use that. Just search for Vedantu college predictor tool. You will get it. Cool. Okay, chalo, let's concentrate now. Concentrate on the class, or else we'll get diverted. Come on, let's move on to the next one. All right. So this is done. Now the next geometry that you need to know is that of a solenoid. Again, this is the next application. Like I said, solenoid toroid of Ampere's law. Here also again, you should remember few more things. You generally remember the formula for a long solenoid. Because when you have a long solenoid which is nothing but turns of coils one after the other, then the magnetic field inside the solenoid is roughly constant. It is parallel. That is why you use long solenoids. What also happens is inside the lines are almost parallel. Like you can see right over here. But the problem happens when you reach the end. So whatever this part is there, it is almost uniform. But when you reach the end, it becomes little weak. But when you come completely outside, hardly any magnetic field is present. So you will see magnetic field outside the solenoid is basically going to be 0. Let me put it here. magnetic field outside the solenoid is going to be negligible. It's going to be zero. Okay, it spreads out so much that hardly any field is there. All the field lines are concentrated only in that region of the coils. The magnetic field in that uniform part is given by this. The magnetic field in that uniform region is given by mu naught Ni. What is this N? What is this N, my dear warriors? This particular N is the number of turns per unit length. If you take 1 meter, how many turns are there? 100, 200, 500, 700. So per meter, how many turns are there? So actually speaking, this is nothing but N by L. N by L. Capital N is for total turns, length is basically L. Is that absolutely very clear? Yes. Yes, Sura, that is exactly my point. And whichever chapters I will give you as a list, I will give you the list of all the chapters, number 1, number 2. Some chapters you will have to go through the flash series as well. The flash series was one of the best series, trust me, for 2024 aspirants. So you will have to go through the flash series also. Okay. And also I hope you know that the crash course is right now available for 999 rupees only. This is that limited edition crash course. If you are not aware of it, please check out the link in the description box or even in the video which I have made. It's just for 999 rupees. That course initially started, at a very high price, and because hardly any days are left and we want to ensure that every student reaps all the benefit, you choose which chapter you want to watch. It's just there for 999. Not just that, with test series, with assignments and the support till JEE Advanced. So it's a proper JEE 2024 crash course. If you pass JEE Mains, 100% your complete support is there for JEE Advanced. So make use of that benefit as well. Link is there in the description box. Cool? Alright. So moving on to the next part over here. When you reach the end, my dear warriors, here the magnetic field is slightly lower. In fact, it is mu naught Ni divided by 2. It is slightly weaker. It is half of the magnetic field as that it is present over here. So this is another important formula which you must know at both the ends. If you take a solenoid and bend it, you take this solenoid, bend it, a lot of pressure you have to apply, bend it, make it into a hollow tube of many coils. You can see this is a hollow tube with coils which are present. This becomes a toroid. It is just like a solenoid only. You can see the formula is actually the same because it is still going to be mu naught Ni only. This N, which is number of turns per unit length, that length of the solenoid, there are N turns. What is the length of the solenoid? It is the circumference of the tube. So that is why it is 2 pi r. So formula wise it has not changed. If you notice, it is still the same as that of the solenoid. Just that here r is the radius of this circle. R is the radius of this circle. That's all. Cool. Shall we go ahead? Right. Moving on to the next one. Coming up on your screen. A long solenoid carrying a current produces a magnetic field B along its axis. If the current is doubled and the number of turns per centimeter is halved, the new value of the magnetic field will be equal to. Okay. Now, a long solenoid which is carrying current produces magnetic field B along the axis. The current is doubled, the number of turns per centimeter is halved. This was asked in JEE Mains 2022. So the formula is mu naught small ni. What have you done? The current is doubled. Great. So this current you have basically doubled. The number of turns per centimeter, that means per unit length. What have you done? You have halved this. 2 into half into 2 will just cancel out. So what will happen to the magnetic field? It will still remain the same, isn't it? It will just remain the same. It will not change at all. So shouldn't that be the answer? Option A. Very good, Tanishka. Right. Yes, Amruta will be putting up the notes after the class is over. You will see it in the Telegram, right? Just like yesterday or day before yesterday's notes, they'll come up as a link in the Telegram. Okay. Why don't we just share the PDF? Because what happens if a student is watching after a few days, then scrolling through the Telegram and all those things becomes a problem. That's why we end up putting it in the description box. and we don't put drive links because of obviously storage issues, drive limitations, and if something happens to Google Drive, then it's gone. So that's why we keep it on our servers so that they are safe, secure, and you will be able to get it, right? Another thing, some students are also asking, sir, can we also get your derivations course, Irodov course, numerical solving course for JEE and other exams? So guys, let me know in the comments after the lecture is over. If you want, I have made special videos for complete this derivations, which are useful for JEE Advanced, because remember in JEE Advanced you need derivations. Number 2, for the Irodov problems, all the important Irodov problems, and number 3, special problems which you will not find in any textbook. I have made a special collection of those problems. And also I have a course for, HC Verma short answer. If you want it as a bundle, let me know if it is going to be useful for you. I know that, but if you want it, then I will make a separate course for it and I will give it to you, right? If you want it, do let me know. I'll make it for a very affordable price for sure, right? Yeah, because many students keep on asking me the same thing and I feel that it will be very, very beneficial. Long solenoid is formed by winding 70 turns per centimeter. 2 amperes current flows, then the magnetic field produced inside the solenoid is how much? Okay. What do you think? A long solenoid is formed by 70 turns, 2 ampere current is flowing, magnetic field produced inside the solenoid is how much? This was in JEE 2023. Use mu naught Ni, that's it, nothing is there. Mu naught value is 4 pi into 10 to the power minus 7. Number of turns is 70 turns per centimeter. 1 centimeter is 10 to the power minus 2 meters. Be careful or else you'll get a wrong answer, into 2. Just do the math and see what you get. You should get it as 176 into 10 to the power minus 4 Tesla. So direct questions do come on solenoids and toroids. Yes, direct questions come on solenoids and toroids. Wow, Yashwant, we have 20-25 aspirant as well watching these classes. Great. Moving on to the next part now, slowly, and this is basically going on to the effects of magnetic field. Till now, magnetic field was produced. Now magnetic field is going to apply on some charge or some current and thereby applying a force. See, remember one thing. If you take a stationary charge, static charge, right, and you apply electric field on it, then you will see that there is a electric force acting on it given by charge into the electric field. That is simple. If you again take this stationary charge and you apply a magnetic field on it, then the force due to the magnetic field will be 0. The force due to magnetic field is 0 on a stationary charge. But the moment it starts moving, apart from the electric force, you also get the magnetic force. That is very crucial. So when you take a charge and the charge is in motion, so if there is electric field, yes, that electric field will apply an electric force which is given by QE. Not just that, if there is magnetic field, then that magnetic field will also apply another force acting on it, and the direction is given by the cross product of the motion, which is velocity, with magnetic field. If you see it is coming like this example, then you will see there is a force due to the magnetic field, as well. Both these forces are applied together, and that is why you will get a net magnetic field. That is why, net force. That is why you'll get a net force. Both the force due to electricity as well as magnetism will come into play and you'll get the net force. This net force is also sometimes called as your Lorentz force. So Lorentz force is the total force of electromagnetic fields on a charge. So when it is moving, magnetic force and electric force both are present. When it is stationary, only electric force is present, magnetic force is absent. Electric force always applies itself in the direction of the field. That is very crucial. Remember this. If you take a positive charge versus a negative charge, imagine this is the electric field, but if you compare it with a negative charge, how will the force change? In the case of positive charge, the force will be like this. In case of a negative charge, the force will be opposite to the field. It's always along or opposite to the field, electric force. But magnetic force is not like that. The magnetic force, this force due to magnetic field is always in the direction of V cross B. V cross B. Keep this in mind. It's along V cross B direction. If it is positive charge, if it is negative charge, it is opposite. So that will come to it. Alright. So either it is along or it is anti-parallel to V cross B. That is how it is. So the formula for that force is Q V cross B. Q is the charge, V is velocity, B is magnetic field. Remember one thing, because the force is a cross product of velocity and magnetic field, hence this vector is not only perpendicular to velocity, but this vector force is also perpendicular to the magnetic field. Because of this, what also happens is the work done by magnetic force is always going to be zero. The work done by magnetic force is always going to be zero. Is that clear, my dear students? Why? Because force is perpendicular to the displacement. Force and velocity and displacement they are going to be perpendicular. So that is why work done is zero. Therefore, only direction can be changed. Only direction can be changed. But magnitude, that is the speed of the particle can't be changed. Because you can't change the kinetic energy. You can change the direction, but you cannot change the speed. That force is perpendicular. So it can't increase or decrease the speed. It can only turn it. That is very crucial regarding this magnetic force. Kinetic energy will remain constant. So you can also mention that as well. So the kinetic energy will remain constant if there is only magnetic field. But yeah, be careful. If there is electric force can change the speed. Electric force can change the speed. Okay. So I'll just mention it over here. Electric field can change both direction and speed. Both. Electric force, right? They can change both the direction also and speed also. Who is that? Electric field. Keep this in mind. Okay, but magnetic field, they can only change the direction, but the speed can't be changed. All these are crucial pointers regarding the magnetic force and the electric force. And this was the Lorentz force, which is the electric force plus the magnetic force, the vector addition of it. So Q is the electric part, Q V cross B is the magnetic part. You take the vector addition of it, you will get the net force acting on a moving charge. Net force acting on a moving charge. I hope this is absolutely clear. Great. Now, there can be many special cases on this when the charge is thrown parallel, anti-parallel, at an angle, perpendicular, etc. The simplest case of them is when the charge is thrown parallel or anti-parallel. Then what happens is the velocity is parallel to the magnetic field. So if you take V cross B, what will the answer be? When the magnetic field is either parallel or anti-parallel to the velocity. When the velocity and magnetic field are parallel or anti-parallel, what will be the V cross B value be? It is the cross product of two vectors, parallel or anti-parallel. Come on, I want everybody spamming the answer in the chat box right away, right now. Show some josh. Show some energy. Don't be lazy to type one simple answer. Just one sec, meanwhile. Very good, very good. Finally, I know people are alive and not just chumma slept off watching the class. Very good. The answer is 0. Yep, that is the answer, 0. So that is why no force acts on it. The force acting on it is 0. So that means the velocity will remain constant as acceleration will also be 0. So the velocity will remain constant. So it will just go along a straight line path. Straight line, uniform speed. It will move uniformly. That is how the motion will be. The problem happens when it is at an angle. We'll come to that. This was a simple question which was asked in 2020. Remember during the pandemic, the JEE Mains exam went till September. Can you believe that? They had a crazy time. I don't know if you know this. Okay, so this is the September. That to the third attempt. There were, remember, once upon a time 3 attempts, 4 attempts and all that. So yeah, gone are those days. Thankfully we have 2 attempts and the exam is getting over early by April and not stretching till September. Okay, so here we have this question, and what was it saying? Charge is given, velocity is given, field is given. Question is find the force in newtons. All you had to do is F is equal to Q into V cross B. First do V cross B. Velocity, you know. Magnetic field also you know. So when you have to do the cross product, do this. Use our matrix method. I, J, K. 2, 3, 4, 5, 3, minus 6. Then you will put I cap, put some brackets, put minus j cap, put brackets, then put brackets and put plus k cap. Plus, minus, plus, right? Get this answer. Whatever answer you get, multiply by the charge, you will get the force. For example, for I cap, hide this column, hide this row. Go like this. 3 into minus 6 is minus 18. 4 3s are basically 12. So minus 12, right? That is how it is. 3 into minus 6 is 18, minus 4 3s are 12. For j, hide this column, hide this row. 2 into minus 6 is minus 12 and minus 4 into 5, which is 20. Then over here, hide this column, hide this row. 2 3s are 6 minus 3 5s are 15. Just do that. Whatever answer you get over here, multiply this entire thing with how much is the charge? 1 microcoulomb. So into 10 to the power minus 6, that will give you the force. That will give you the force in Newton. So you'll get something I cap, something j cap, something j cap and something k cap. Okay, so that is how you will get the answer as. See if you get the answer as minus 30i plus 32j minus 9k. Okay, so you should get the answer as minus 30i cap plus 32j cap and minus 9k cap. This is what you should get the answer as. Is that okay, my dear warriors? And one more thing, this was 10 to the power minus 3 Tesla. So whatever you get, also multiply by 10 to the power minus 3, because this was 10 to the power minus 3 Tesla right over here. Okay, and this answer, whatever you get, will have minus 6 and minus 3 becoming 10 to the power minus 9. So this is how you will get it as. Put the Newton later on. Put the Newton later on. 10 to the power minus 6, 10 to the power minus 3 will come over here. This is because of the charge, 1 microcoulomb. So remember, you have to also take charge into account. And 10 to the power minus 3 came over here. So just do that, you will get the answer. Yes, everyone, this kind of question can come. It will eat up a lot of your time. It will eat up a lot of your time. But one thing is there for sure, it will guarantee you marks. This is just going to eat up your time. That's all. Okay. Then the second important situation or case is where the charge is going to go in a circular path because you have thrown it perpendicular to the magnetic field. When you throw it perpendicular to the magnetic field, the force is also perpendicular to that. Look over here. Velocity is like this. Magnetic field is inside. You can see these crosses everywhere. Magnetic field is inside. So if you do velocity cross product with magnetic field, the force is here. Velocity cross magnetic field, force is here. Velocity cross magnetic field, force is here. Force is always redirected at the center. That is why it goes in a circular path, and this force behaves like the centripetal force. And centripetal force will be mv square by r, and that force is provided by the magnetic force. The magnetic force is qvb. So that is why q into v into b will be mv square by r. This is how you have to remember it. It is going to be a uniform circular motion. Remember that. Uniform circular motion. The magnetic force provides the necessary centripetal acceleration. It acts like the centripetal force. So that's why mv square by r is qvb, qv cross b. That's all. qv cross b. The cross product will be sine 90 because velocity and magnetic field are themselves perpendicular to each other. If you find the radius, time period, etc. by solving this, you can see velocity will cancel. From this you will get the radius, you will also get the time period, everything. The radius is mv by qb. This is the major formula which you should remember. I'll come to this in a bit. For now, second thing is time period formula. These are the two main things which you will remember. What I have added here are the different types of or models of question which have been asked or which can be asked. Meaning, see, mass into velocity is momentum. So there might be a question, what is the ratio of the momentum of the particles being projected? Sometimes it could be like the energy of the kinetic energy of the particles is given. We know momentum is root 2 m times kinetic energy. That is why the kinetic energy. Sometimes the particles are accelerated through a voltage difference. So the kinetic energy will be charged into the accelerated voltage. If you notice, Q is there here also, root Q will cancel, root Q will be there below. So these are the varieties of question that can be framed. If you know this, you can get to any of these things. Did you understand it? Mass into velocity, momentum. Momentum is root 2 times m into kinetic energy. Kinetic energy of the charged particle can be obtained when you accelerate the charge through a voltage, 5 volts, 10 volts, 100 volts, like that. So charge into voltage gives you the kinetic energy, right? And charge cancels, you will get this. Will you remember all these formulas? No. Only formula which you have highlighted. Time period 2 pi m by qb. This is again very important. You can be asked frequency. So frequency is asked is 1 by time period. So it will be qb by 2 pi m. Don't remember frequency, just remember time period. Omega, angular speed is asked. Angular speed is 2 pi by time period. Angular speed is 2 pi by time period. So it will, you can just take time period below. 2 pi is there already. qb by m. So qb by m will be angular speed. Don't have to by heart this, only by heart these two. Is that absolutely clear? Yep, very good. Awesome. Yeah, the session will continue for more half an hour, 25 minutes or maybe 45 minutes, not more than that. Yeah, we are nearing the end of the things. Many things are almost done, right? Don't worry. Okay. Another important variation in the problem is when the charged particle is not thrown perpendicular but at an angle like this. Velocity makes an angle with the magnetic field. That velocity has two components. One is perpendicular, one is along the field. Remember, the component which is parallel to the field will not be affected only by the field. So this part will remain uniform. This will remain constant. This will not change at all. This part is the part which will change, but since the velocity is already perpendicular to the field, we know what should happen. Whenever velocity is perpendicular to the field, it has to go in a circular path. So that is why this part is responsible for the uniform circular motion. This part is responsible for maintaining a straight line motion. If you combine both these things, this is going in a circle and this is making it go ahead. If you combine this motion, you will get this motion, which is a helical motion. What is this motion called as? Helical motion. This motion is called as a helical motion or helix, spring-like motion. And it is a combination of circular motion and the motion of the circle is along the axis of the circle. That is a helical motion. Keep this in mind. Now, in this helix, you should know certain terms. The distance between one turn to the next turn is called as the pitch of the helix. It is called as the pitch of the helix, which we have already covered even in the older classes, and you should know about what is the meaning of a pitch. Even it is there in the units and dimensions chapter for micrometer screw gauge. You rotate the screw once, how much does the screw go ahead by? You go around once, how much do you go ahead by? That is called as the pitch of the helix. Correct. That is called as the pitch of the helix. Very good. And this pitch is nothing but the parallel velocity. You are going like this with some speed. You are going like this with some speed, but you have to wait for one rotation to happen. So that means you are going with that speed for one time period. So that is V parallel into time period. That is what the pitch is. V parallel is V cos theta. What about the radius? What about the radius of this circle? What about the radius of this particular circle? You can see this circle is just there, right? What is the radius of this particular circle? That radius, that particular radius is just going to be mv by qb. Remember the same formula I gave it to you over here, mv by qb, but that velocity will be the perpendicular component. So mv perpendicular by qb. That's the only difference. What about the time period? What about the time period? Time period formula can't change at all. So the time period, sorry, 1 second. This was the radius. The time period formula can't change at all. So this time period that you have, this particular time period that you have, it is again 2 pi m by qb. Same formula which I gave you over here. 2 pi m by qb. 2 pi m by qb. That is the time period. It will not be dependent on the speed at all. Yes. Let's move now to some questions. So I have just posted all those things over here in the printed form also. Okay. The pitch, the time period, the radius, all the same things which I have written over here. Okay. It's there in the printed slides. We'll be getting the slides in the Telegram group. Make sure you're a part of the Telegram group as well. Electron going perpendicular to the field undergoes circular motion. Radius, what is the speed of the electron? So this is a direct question which can come in JEE Mains. R is equal to mv by qb. Question is to find the speed of the electron. So v will be r qb divided by m. So radius is known. Yes. Where is it? I know the radius. Is charge known? Yes. I know the radius is 2.8 into 10 to the power minus 3. Charge is 1.6 10 to the power minus 19. Is the magnetic field known? Yes. It is basically 0.5 Tesla. Whole thing divided by mass. The mass of an electron is close to 9 into 10 to the power minus 31 kg roughly. So when you substitute all the values, you can find it out, calculate it, close to 2.2 10 to the power 8 meters per second. So that is how you find the answer. Direct substitution, all right? So this problem is very, very simple. As you can see, it is completely based out of the formula. Yeah. Are you supposed to memorize the formula, masses of electron, proton, and the charges? Answer is yes. It is better to remember the mass. Okay, it is better to remember the mass of most of these things. Cool. How many of you remember all these masses, constants, everything by heart? Let me know. If you know it, really hats off to you and good. Keep up the good work. Next question, proton and alpha particle move perpendicular to the magnetic field. The mass of alpha particle is 4 times of the proton and the charge is twice of that of the proton. Okay, that is actually supposed to be your general knowledge. It's not supposed to be given over here. Ratio of the circular paths radius followed by them if both have equal kinetic energies, second accelerated through the same voltage difference, R. Interesting. So there are two varieties of problems that will come. So let me just make two duplicates of it. Let me solve one by one. Let's solve this first. Oops. Let's solve this first. Equal kinetic energies. Now find the ratio of the radii. Radius, remember, is mass into velocity by QB. Remember, mass into velocity was momentum. So momentum by QB. Remember, momentum was root of 2m times the energy of kinetic. This divided by QB, right? That is what it is. So over here, I will come and stop and then think what and all do I know is constant and not constant. Equal kinetic energy, that means this I know is the same. Magnetic field, obviously same. 2 is a constant, it's a number, that is also same. Mass and charge will be different. So can I say the radius is directly proportional to root of mass and inversely proportional to the charge? Right? So if I do a ratio of R of proton upon R of the alpha particle, I should get this as root of mass of proton by mass of alpha particle and inversely proportional to the charge, right? So charge of proton here, charge of alpha particle over here. So what do I get? Mass of proton and mass of alpha particle, that is 1:4. Charge of alpha particle, that is basically 2:1, right? Because alpha is 2 positive charge, proton is 1 positive charge. So what do I get? 1/4 is 2, because the root of 1/4 is 1/2. 2 cancels. I'll just get this as 1:1. I'll just get it as 1:1. How many of you got this now? Everybody with me? Very good. Excellent. Now let's move to the second part of the problem. First part is done. Let's go to the second part, part B. We are solving part B. They are accelerated through the same voltage. Till this point, we have got radius is root of 2 times m times kinetic energy divided by charge into magnetic field. Because I am accelerating through the voltage, therefore the kinetic energy must be charged into the voltage by which I have accelerated. By QB. QQ will cancel root of it. So I will be left with, 1 by B will be there. Here root is there, M is there, Q has gone, accelerated voltage, root Q goes, Q stays below. This is what I will get the radius as. Now over here, what and all will be constant? They are accelerated through the same voltage difference. 2 is a number. Okay, B is also a constant. So this means radius is directly proportional to root of mass by the charge. So therefore, radius of proton by radius of alpha will be root of m by alpha, mass of proton by mass of alpha and inversely proportional to the charge. So charge of alpha by charge of proton. So mass of proton by mass of alpha is 1/4. This is 2/1. 2, 4 cancels, becomes 1/√2. So 1/√2 should be the answer. 1/√2 should be the answer. Everybody clear till this point? Very good. So these kind of questions can come in your JEE Mains exam. Momentum is equal, radius is equal, charges are equal, masses are equal, accelerated voltage is equal, find the ratio of this, find the ratio of that. Standard question. Every shift will 90% of the times have this, especially with regards to magnetic field. Okay, time period of a charged particle undergoing circular motion in uniform magnetic field is independent of its. I want everybody out here to spam it. Subhrakanti, it is not √2:1, it is 1/√2. Be careful, it was proton by alpha, so it will be 1/√2. Not √2:1. √2:1 will be there in the option, but you will not mark it, or else you will get a wrong answer. Okay, be careful. Okay, what do you think is the answer for this? Yes, it is independent of the speed because the time period is 2 pi m by qb. It is dependent on mass, charge and magnetic field. All the three other things are there. Speed is not there. So it is independent of the speed. What about this question? A particle of charge q mass m starts moving from the origin under electric field, magnetic field and velocity is there. Speed will become 2v0 after how much time? This is a very good question. You will see why. First draw everything. Okay, so you have the charge over here, let's say it is q, and it has some velocity which is v0 j cap. Okay, electric field is in I cap direction. Okay, so the velocity is like this, it is v0 in the j cap direction. Magnetic field and electric field both are in this particular direction. This is E0, this is B0. This is B0. Okay. Now realize one thing. Magnetic field can never change the speed. Got it? Magnetic field can never ever change the speed. In fact, electric field only can change the speed, number one. And because of the electric field, it will accelerate like this. But at the same time, due to the magnetic field being perpendicular to the velocity, it will go in a circular path. So the path taken by this will be something like this. It will go down like this, come up. It will be helical in nature, but you know what? The helix pitch will not remain the same. In fact, the pitch of the helix will keep increasing. It's an helix. It's a helix with increasing pitch. Helix with increasing pitch. That is the beauty of this problem. Because the horizontal component is not remaining constant. Why? Electric field is accelerating it. Magnetic field is making it go round and round. So electric field is the culprit over here. What a brilliant, brilliant question. Hello Utkarsh, namaste, namaste, namaskaram. Alright. So now the speed of the particle will become 2v0. So if it has to become 2v0, realize the horizontal component will come. That's the only thing which will happen. So v0 is going to be there. Because of the electric field alone, some velocity might be there. I don't know. And the resultant of these two, my dear warriors, the resultant of these two, that is going to be 2v0. So how much is this v going to be? That's not difficult to find out, because 2v0 whole square will be nothing but your v0 square plus your v square. So therefore v square will be 4 minus 1, which is 3v0 square. So therefore v will be root 3 times of v0. This velocity, why did it come? Only because of electric field. So what is the acceleration due to the electric field which is produced? So that acceleration due to electric field will be the force, divided by the mass. The force is charge into the field. Mass is basically m. That is the acceleration. That is number one thing. And I can say this velocity is initial velocity, which was 0, because all the velocity was in the y direction. Nothing was there in the x direction. 0 plus acceleration into time. The v value is root 3 times v0. Acceleration value is qe by m into t. So what is the time? It is basically root 3 m v0 by charge into the electric field. What a brilliant question. What a brilliant question. Answer is option number D, which is root 3 m v0 by qe0. Isn't that amazing? Sir, what is an axis in a circular loop? Axis in a circular loop means if you take a circle, you draw perpendicular to the circle. This is the circle. You draw perpendicular to it, passing through the center. That is the axis, right? Correct. That is the meaning of axis. Axis of a cylinder. You take a cylinder, that is the central line which is parallel to the walls. If I take this container, if I ask you what is the axis of this, is that line which is like the line of the symmetry. So if I take this vessel, this is the axis, this particular line which passes from the center, from this face and comes out from here, right? This is the axis of the vessel. Same way, axis of the coil, loop, etc. Okay. Now this was done. Yes, this was done. Right. Perfect. Let's come to magnetic force on a current carrying conductor. So if a charge can experience force, even a current carrying wire experiences force, because current carrying wire is a moving charge. It has many moving charges. Yep, I hope this is very clear. So the force acting on it is given by I L cross B. What is I? Current in it. What is L? Length of that wire which you are considering. Is it a vector? You have made it a vector. How did I decide the direction? Whatever is the direction of the current is the direction of the length vector. Magnetic field is not the magnetic field by the wire. It's the magnetic field from somewhere else. Some other wire, some other magnet, some electromagnet, solenoid, toroid, doesn't matter. Some external field. So it is the force acting on the wire carrying that element. Is that okay? Right. Last step of what? This one? Where did it go? This one, I just said, because it accelerates, the velocity will be u plus at. U is 0. Why is it 0? Because it had velocity only in the y direction. So u plus at. Acceleration is charge into field by mass. I got it by force by mass, Newton's law. So it is q E naught by m into t. So what is time? M is on the top, q E naught is below. So I got the time. Is that okay? Cool. All these velocities were in the x-axis only. Remember, this was in x-axis. All these velocities, right? It was horizontal. The net velocity will be the resultant of this vertical and the horizontal component. Why is there this slide? So if you have a straight wire, then you don't have to do dl and all that. You can just say IL cross B. So you remember, this force is again perpendicular to the length also and perpendicular to the magnetic field as well. Is that right? Yeah, it is perpendicular to both the length as well as the magnetic field. So there are certain cases where there is no force, like example, the magnetic field, imagine it was along the wire, then obviously there will be no force only. Imagine this situation. The wire is like this, carrying some current, and the magnetic field is also like this, parallel or anti-parallel. In that case, obviously you will not get any force at all. Another important thing is, if you have a loop of wire carrying some current like this, a loop of wire, this is a loop of wire carrying current, okay, like this. If at all you show some magnetic field passing through it, but the magnetic field should be necessarily uniform, then 100% the net force acting on it, is a big fat 0. No force will act on a complete loop carrying current. Very important. No net force will act on a loop which carries current. Keep this in mind. And if it is not a complete loop, let's say it's a curved wire which carries some current like this, and let's say there is some magnetic field over here. Let's say there is some magnetic field over here like this. Then the net force acting on that particular curved wire, is just the same as the net force on a straight wire connecting the endpoints. So it will be IL effective length cross magnetic field. What do I mean by effective length? You just join these 2 points. You will see this length is called as the effective length. This length is called as the effective length. Okay. So it is IL cross B. L is the effective length. So that is why it becomes very simple to calculate force on curved wires. And also, if you go to the loop, the effective length of a loop is 0, because the start and the end, here the start and end are different. In loop, start and end are same point, so there is no length. That is why the net force is also going to be 0. These are all important things which you should know. Everybody clear? So many things you are learning, so many mistakes you might have been making. If you have to revise here You have to keep up to the challenge. You have to ensure that you learn each and everything. Moving on to the next one. When there are two wires, either parallel or anti-parallel to each other, a wire's magnetic field which passes through the other wire applies a force on it and might either attract it or repel it. So it so happens that if the directions are same, they will attract. If the directions are opposite, they will repel. How do you remember whether they will attract or repel? It's opposite to that of electrostatics. Positive will repel. Same will attract. Here, positive charges repel, but in magnetism, same direction will attract. Positive in electrostatics attracts. Here, opposite currents will not attract, it will repel. That's how you can remember it. Is that clear? Yes. So that is a easy peasy way of remembering this. Correct. And you should also know the force acting per unit length, which is given by mu naught current 1, current 2 by 2 pi into the separation between them, 2 pi d. D is the separation between them. This is the force acting per unit length. You can definitely get some amazing questions also on this, like there is a wire, and this is a standard question which is there in many PYQs also and many books. There is some current over here, and then you have a loop over here. You have a loop over here like this, and let's say it is carrying some current, let's say capital I, like this. So will that loop experience any force, torque, whatever? So what you should do in such cases is that due to this wire, there will be some magnetic field. So the current is going like this. Hold the thumb like this. Fingers are going in. So the magnetic field over here is inside. Magnetic field over here is inside. But as you go far away, the field strength will reduce. So maybe by the time you reach here, the magnetic field might be very less. Here it will be even less. Correct? So as you go far away, the magnetic field strength will keep on changing. Keep this in mind. Keep this in mind, right? The magnetic field strength will keep on changing, reducing. So the force will also keep on changing. That is another thing which you should remember. Now, if you talk about this wire, this part, both the wires are in the same direction. Same means not repel, they will attract. So there will be a strong force of attraction. This wire and this wire, they are opposite currents. They will obviously, opposite currents will repel. Opposite currents will repel, but the repulsion will be less. Now this wire has carrying current like this. The current is going like this. So length is there, magnetic field is inside, length cross B is up. Length cross B is up. So the force will keep on changing at every part, starting from here like this, like this, like this, like this, like this. It will keep on decreasing like this because the field is reducing. Same thing over here, current has changed, reverse the direction. So force will also reverse the direction. So the forces will be basically like this. You will see the forces will keep on reducing like this. These two will cancel each other. The net force in the y direction, they will cancel each other out. They will cancel each other out. But in the x direction, they will not cancel. In fact, in the x direction, the force will be towards this side. The force will be towards this side. It is not zero. In fact, it will be towards the left hand side, because this is high, this is low. This is more, this is more. This force is going to be less because the field is less. So that's how you get it. If you ask me if there is any torque acting on it, torque will not be there. Net torque on it will be zero, because these forces, everything is on the same line. This force, this force, this force, this force, everything is on the same line. It will not rotate. It will just translate. This is a beautiful question which can be there. So Priya, flash series is there in the old videos. Just you have to go to the home page and just check the past videos. You will get it. Okay. I think there will be a playlist also. Right. All right. All right. Yes. All right. Where did it go? You just go over here in the past videos, you will see it. Just go to the live section and you can see over here, these are the old videos. Just go down a little bit before the board exam. Where is it? Yeah, this is still boards. Wow, we have done a lot of videos, yeah, in the last 1 month. Yeah, you can see the last flash was probably just before the JEE Mains examination. So, oh, this is Flash Pro. This was also after JEE Mains. So there was some flash lectures which we conducted after JEE Mains first attempt also. Those things are also there. And over here, you can see all the flash series lectures are there right over here. All the flash lectures are there. Even the paper discussions are also there. So lot of things we have conducted. If you watch these classes also, trust me, it is going to take a lot of time. See thermodynamics, statistics, semiconductors, logic gates, vector algebra, thermal expansion, KTG, thermodynamics, current capacitors, AC, PYQs, chemical bonding, right? Everything is there. Current electricity, modern physics, PYQs on that. So much is there. So guys, the channel is full of content, in pure content and quality content. That is what, you know, I believe in, because content is the king. Content is what is you guys want. You don't want unnecessary nonsense, and that is the reason why I'm here. That is the reason I'm building up this strong team for all of you. So make sure you are watching these classes, right? Don't let this content go waste. And especially if you are studying in English medium, this is the best channel. Rather, this is the only channel which does work for JEE English students from past. It's almost now going to be 4 years, 3.5 years to 4 years, right? Yeah. All right, so let's continue. This is the next question coming up on your screen. Let's see if you guys can do it. We are coming close to the end of this session. After this, only magnetic moment is there. A wire is bent as shown, then the current is I. Question is, what is the force acting on the wire? Okay, first of all, it's a bent wire. What you can do is you can convert it into one single wire joining the endpoints. Joining the endpoints, this is R, this is R, this is R, this is R. So the total length, won't it be 4R? R, 4R, right? So what is the force? It will be I, L effective into B into sine theta. L is like that, magnetic field is towards you, so sine 90. So it will be I 4R into B. 4IRB, yes, or 4BIR. That is the answer. Is that okay? Just use the property which I just told you some time back. Perfect. Let's go on. Let's go on. Now, magnetic moment of a current carrying coil. See, remember, a positive charge and a negative charge makes a dipole. It makes up a dipole, and it has a dipole moment like this, given by charge into the separation between them. This is a electric dipole. In magnetism, you have a north pole, you have a south pole. The north pole has a polarity of plus QM, south pole has a polarity of minus QM, and together, right, it becomes a magnetic dipole. Always dipole moment points from negative to positive charge. The magnetic dipole moment is the charge value of the magnetism. This is not coulombs, this is magnetic charge or magnetic pole strength into the separation. This is a magnetic dipole. Now what happens is, you take a wire or a loop or coil or a solenoid which carries some current, all right, which carries basically some current. Just like this north-south pole of a bar magnet creates a magnetic field around it, this loop carrying current also will create a magnetic field around it, Everybody with me? Just like this guy is also going to create a magnetic field around itself. This is going to be the magnetic field around it. So these two are identical. So why not call this part as the north pole. This is like the north pole, and the bottom one over here as the south pole of this particular electromagnet. So this is also a dipole at the end of the day. This is also going to behave like a magnetic dipole. So I can just mention this is also a magnetic dipole, and this is actually an electromagnet. Electromagnet because I'm passing electricity. I'm passing electricity to create the magnetic properties. So even this will have its own magnetic moment. This will also have its own magnetic moment. This M is given by the formula just like NTA, National Testing Agency, same way NIA, National Investigation Agency. So NTA created some mistakes, let's say, in the question paper. So who will come to rectify it? NIA. Just take it as a trick to remember. NIA is not for testing NTA. Okay, it's not reality. It's just for your remembering purposes. So NIA, National Investigation Agency. That is the magnetic moment of a coil which carries current. And the magnetic moment, remember, is a vector quantity, and it is always in the direction of the area vector. Area vector is just the vector which is going to be perpendicular to the plane of that coil. So if the plane of the coil is like this, the area vector will be like this. How do I decide it is this way or this way? Use your right hand rule. Curl the finger, see where the magnetic field is going. That is the direction of the magnetic moment or even the area vector of it. Cool. So NIA, and N is the number of turns, I is the current, A is the area of the loop. Okay, N is the number of turns, I is the current, A is the area of the coil. Everybody clear about this? Yeah. Cool, cool. Right, moving on to some questions. Look at this beautiful question which is there. It's a square loop which has been bent. Meaning, imagine this is like your book. Okay, this is your book. The wire was going like this. The wire was going on the outer periphery of this book. Imagine you bend the book like this. Are you able to visualize? You are bending the book like this. So this diagram is exactly like that. The loop is now in two different perpendicular planes. Two different perpendicular planes. I hope this is clear. Vanakkam Shaktidhar. Okay. Shriyansh, I know very little Telugu. I can understand little bit of Telugu. Definitely. Yep. Okay. Because most of my, you can say Khandan or my lineage, half of it or part of it definitely comes from Andhra, especially Kurnool, right? All these areas, Hyderabad. And yeah, that is why I know a little bit of Telugu. All right. So over here, what is the thing? These two things are perpendicular. Question is to find the magnetic moment. I'll solve it like this. Imagine the entire loop was actually flat. Entire loop was actually flat. Then the magnetic moment would be NIA. Number of turns is 1. Current passing through it is 2. Area of the coil is 10 centimeters. So 0.1 multiplied by 0.1. That is what it is going to be. So 2 into 10 to the power minus 2. Right? Number of turns has no unit. Current is ampere. Area is meter square. So ampere meter square is the unit of magnetic moment. Now, if I only consider half of this loop, how much will be the magnetic moment of only the half part of it? Only the half part of this particular loop. Think about it. It will be half of this magnetic moment. It will be half of this magnetic moment. So this will be 10 to the power minus 2 ampere meter square. 10 to the power minus 2 ampere meter square. Is this very, very clear? Is this very, very clear? Each half is going to be half of this total coil's magnetic moment. Now take this and bend it like that. Exactly what we need. So you take this like this, and you place the other one, you tilt it, rotate it by 90 degree, so it will be like that. It will be like that, and you just place them together. Now you just place them together like this. Now what will happen? One of the magnetic moment is going to be like this. Let me draw it in different color. Yeah, one of the magnetic moment is going to be like this, and the other one is going to be like this. Is that clear? Both of them are going to be perpendicular. So what will happen to the net magnetic field? The net magnetic field will be, magnetic moment will be like this. This is the net magnetic moment, and the net magnetic moment will be this square plus this square, both of them are equal, so it will become √2 times any of these magnetic moments. So √2 times 10 to the power minus 2. √2 times 10 to the power minus 2. Is that clear? Everybody with me? Understood? Clearo? Perfecto? Very good. Very good. So this is how you can solve this particular question, right? You first find the magnetic moment due to the entire loop, right? And you find it out to be 2 into 10 to the power minus 2 ampere meter square. You find any half part of it, okay? And then you go ahead with it. Acha, but here there is one problem. Here they have mentioned each side of the loop is 10 centimeter. So technically speaking, I'll tell you one small mistake what we have done. Here this and this and this and this and this, each one is 10 centimeter. Each one is 10 centimeter. So technically speaking, this is not going to be 0.1. This whole side is going to be, imagine if you make it flat, this will be 0.1 plus 0.1, this will be 0.2. This will be 0.2. I hope this is very, very clear what I'm saying. So technically speaking, this is going to be 0.2, because this is 0.1, 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 this is 0.1. If you make it flat now, it will be 0.2 by 0.1. So technically this will actually be 4 into 10 to the power minus 2. 4 into 10 to the power minus 2. And because of that, even this will be 2 into this, and this will be also 2 into 10 to the power minus 2. So all our answers will also get multiplied 2 times, and you will get this as 2 root 2. You will get this as 2 root 2 into 10 to the power minus 2. Right? Everybody with me? So this will be basically 2 into 1.4 into 10 to the power minus 2, which is 2.8 into 10 to the power minus 2. 2.8 into 10 to the power minus 2. Is that clear? Very good. So that is the final answer. So I think it is 0.028. That is the correct answer. So here the whole side length was not 10. This was 10. This was 10. Okay. So I have made the modification accordingly. Great. Great. Direction is wrong. Don't worry about the direction. See, KKB, in these problems, direction is not even asked, number one. Number two, I didn't even bother about the direction. Reason being, I'm interested in their relative directions. They will be perpendicular, whether in and out like this, or like this and like this, or like this and like this, doesn't matter. As long as they are perpendicular, it doesn't really matter, because the magnitude is what has been asked. But yeah, if you go with the actual directions and all that, then you can say, okay, it will be like this, it will be like that. But that doesn't matter only in this problem. So in the exam also, don't waste your time finding the actual directions. Where it matters, there you find. Where it doesn't matter, don't break your head. You know it is going to be parallel, you know it is going to be opposite, you know it is going to be perpendicular. Don't worry, just find the magnitude and use the formula. Is that understood, my dear students? Where you should worry, where you should not worry. Clearo, can we go ahead? Alrighty, alrighty. Let's move ahead to the next question coming up on your screen, my dear students. What is the next question? It says that there is a square loop which carries a current, and steady current is I, magnitude of the magnetic moment is M, square loop, okay? If the square loop is changed to a circular loop, same current, the new magnetic moment, 2019 question. All right, so just imagine this is your square loop. It has some magnetic moment M, and let us just assume the total length of the loop is L and each side to be A. So it will be 4A, which is the perimeter, 4A, which is the perimeter. The magnetic moment, which is NIA, number of turns is 1, current is I, area is A square. Area is basically A square, correct? A into A is A square, but A from here is L by 4. So it will be I into L by 4 square. So it will be I L square by 16. That is the magnetic moment for a square. Magnetic dipole moment for a square. Now let's go to the circle. Let's go to the circle, my dear warriors. Cool. Now if you take a circular loop, then the magnetic moment, again using NIA formula, this is for the circle, M naught I will call it. Number of turns 1, current I, area is pi r square. Okay, pi r square. Now what is this r going to be? Think about it. The circumference, which is the same length L, will be 2 pi r. Will be 2 pi r. So what is r? R is basically L by 2 pi. So squaring r, that means L by 2 pi whole square. This I will get it as pi L square by 4 pi square, which with the current value, So this will become I L square by 4 pi. I L square by 4 pi. Now what do I do? Check this formula and check this formula. I L square by 16. So from here, can you see I into L square is basically 16 times of M. I into L square is basically 16 times of M. So instead of I L square, put over here 16 times of M. Rest of the things as it is. Divided by 4 pi. 16 by 4 becomes 4. So 4M by pi should be the answer. 4M by pi is there as option number D. Yes, that is the correct one. Perimeter, total length remains the same is the concept here. The total length before and afterwards is same. Here it is 4 times the side length. Here it is 2 pi times the radius. Side will get as L by 4. Radius you will get L by 2 pi. Substitute in NIA formula and you will be able to get it. That's how simple this is. Right? Cool. Now that you understand how to calculate magnetic dipole moment, we have taken some really good questions. What happens when you take this magnet, and place it in not its own field? Obviously own field can't affect itself. You place this in somebody else's field. So it will experience a torque. It will behave like a spring with some energy stored in it. There will be no force acting on it. Always remember, the force on a dipole, net force, is 0. Because whatever force is applied on the north pole, same force is applied on the south pole, and they are equal and opposite. So that is why always the net force on a magnetic dipole placed in uniform field is 0. In uniform field only. In non-uniform, it may not be 0. And you can think of some clear, simple explanations, like, say for example, let's say this is the north pole, let's say this is the south pole. Okay, this is the north pole, this is the south pole, and let's say the magnetic field is like this. Here it is weak, here it is strong. All right, here it is weak, here it is strong. Then what will happen on the north pole side? Because of this magnetic field, the force will be in the direction of the field, but it will be smaller. It will be a small or a weak force. On the south pole, it will be opposite, but it will be slightly stronger. So the force on the south pole will be definitely strong. In this case, if you calculate the net force on the dipole, you can see it is definitely not a 0. And this is true for non-uniform fields, for non-uniform external fields. Is that clear? So dipole's force is 0 in uniform field. In non-uniform field, it may not be 0, like you can see right over here. Yep, very good. But the torque acting on it depends on the orientation, how it is oriented. What is the direction made by the dipole moment with the magnetic field? And the torque formula is similar to the torque formula in electricity. Even the energy formula is similar to the energy formula in electricity. Observe this. If you find the torque on a dipole in an external field, just like in electricity, it was P cross E. Instead of P, you have M, magnetic moment. Instead of E, you have B, magnetic field. So M cross B. M cross B is the formula. The formula is M cross B. MB sine theta. If magnetic moment is parallel to the field or anti-parallel to the field, cross product will be 0. So that's why 0 or 180, it is going to be 0. In fact, these are the two conditions for equilibrium. Equilibrium. One is stable, another one is unstable. One is stable, another one is unstable. Which is stable, which is unstable? Well, this one over here is basically stable. I don't know whether I have some space over here. This is basically stable equilibrium. Whereas this one over here, 180 degrees, this is unstable. This is unstable when magnetic moment and magnetic field are opposite in direction. Magnetic moment and magnetic field are in opposite direction, that is unstable equilibrium. When magnetic moment is perpendicular, that is maximum torque. That is basically your maximum torque. That is also an important condition which you should know. That is with regards to torque. So there is a torque which is always going to bring that magnetic needle, magnetic compass, magnetic bar magnet, whatever, or electromagnet, it will try to bring it in the direction of the field. That is the torque's function. It is always going to be restoring it back to its stable position at 0 degree. It's happy. Stable means it is happy. It will always bring it parallel, align the field and the magnetic moment. That is how a magnetic needle functions, no? That always the needle tries to align in the Earth's magnetic field. That is the whole purpose of the compass, and this is the working principle of it. Energy wise, it is minus m dot b. I don't think it is there over here. Yeah, I'll just put the energy formula maybe on this slide. Yes, the energy formula. Potential magnetic potential energy is minus m dot b. Keep this in mind. So it is minus mb cos theta. That is the potential energy formula. Minus m dot b vector. Same thing like electrostatics, it was minus p dot e. Okay, no difference. Let's solve some questions based on magnetic dipole moment coming up on your screen. A magnetic moment m having rotational inertia I is placed as shown. The angular speed when it rotates by 90 degree under external field. I don't know whether this diagram is very clear, but I'll explain this to you. Supriya sir, similarly in Amperian loop to determine the direction of the current, can we choose any direction of the loop and it won't matter? Yeah, you can choose any direction of the loop. The sign of the current will change accordingly. The answers will accordingly come properly only. There is no need that you have to go clockwise or anti-clockwise for Amperian loop. What direction to choose for curling your fingers in Amperian loop? You can choose any direction, Supriya. It doesn't matter. Automatically, the thumb will be the positive sign convention. All those currents in the direction of the thumb will be positive currents. Other currents will be negative. Okay, so it doesn't matter how you travel in an Amperian loop. There is no rule that you have to go clock or you have to go anti-clock. Am I absolutely clear? Yeah? Okay, right. Let's do this. So first of all, I don't know whether you are able to see it very clearly. There is a south pole over here. There is a north pole over here. So there is an external magnetic field which is coming from this magnet like this. And there is a loop which is placed over here. There is this loop which is placed over here that creates its own magnetic moment. Okay, there is a loop over here, magnetic moment. It is right now perpendicular like you can probably see. So this magnetic moment after some time will rotate, it will experience a torque, and because of which it will rotate and it will align itself like this in the direction of the magnetic field, in the direction of the magnetic field. So in this process, obviously it will gain some kinetic energy, it will have some angular velocity and all of that, and that is exactly the question. What is that angular velocity by the time it has rotated? By the time it has rotated, earlier it was here, it has come from there to here. Okay, it has come from there to here. So to solve this question, use the energy principle. It will be very, very simple. Use the energy conservation. Initial potential energy plus initial kinetic energy will be final potential energy plus final kinetic energy. Now over here, what is initial, what is final is the crucial part. See, initially it is at 90 degree. So energy at 90 degree plus kinetic energy initially is, finally it is making 0 degree. So energy at 0 degree plus the final kinetic energy. When you are at 90 degree, if you use the formula minus mb cos 90, that is the formula. Kinetic energy, it was at rest, so 0. When it is at 0 degree, theta is 0. So minus mb cos 0 plus final energy is half I omega square. That is the way you solve the problem. Cos 90 is obviously going to be 0, so don't bother. LHS is 0. So minus mb cos 0 is basically 1 plus half I omega square. Bring this over here. So mb will be half I omega square. So omega square will be 2mb divided by I. So omega will be root of 2mb by I. Root of 2mb by I. That is option number B. You can see that right over there. Correct? Can you see that? Omega will be root of 2mb by I. That's how you solve this question based on energy. Did you love this question? Did you love this question? Very good. Moving on then to the next question. This is asked in previous years in 2020. There is a coil which carries some current. It is placed in some field such that when you rotate it slightly, it performs simple harmonic motion. The mass of the loop is m. Then what is the time period? I'll explain this to you in a very simple way. See, this is that loop which carries some current. This produces its own magnetic moment, capital M, and the magnetic field is also perpendicular to the coil. That means in the direction of the magnetic moment. This is how it is right now aligned. This is how it is aligned right now. Initially, the magnetic field is perpendicular to the plane of the coil. You can see the magnetic field is perpendicular to the plane of the coil, but theta wise it is 0 between B and M. Now imagine somebody rotates the coil slightly like this. Somebody rotates the coil slightly like this by an angle theta with respect to the magnetic field. What do you think will happen? Obviously there will be a torque which will be there, and this will be restoring in nature, which will make it oscillate. And we can find this torque very easily because this torque is opposite to theta, opposite to the displacement. Can I not say, we can find this out, torque is equal to minus, because it is opposite in direction to theta, minus mb sine theta. Why is this minus? Because it is opposite, but magnitude wise it is just mb sine theta, so we don't need that minus sign technically. I know I'm just finding the magnitude. M is m only, b is b only, sine theta will be theta if the angle is very, very small, and you can read the question carefully. It is slightly, slight means what? Theta is very, very small, so that is the reason why theta will be sine theta. Now you know this is just like saying torque is proportional to theta, so this is the constant of proportionality. This is the constant of proportionality. So using that we can find the time period. This is your SHM, simple harmonic motion. So in simple harmonic motion, the time period will be 2 pi root of, instead of mass you will have moment of inertia. instead of K, you will have M into B. Now the only problem is, what is this I? What is this I going to be? What is this I going to be? What do you think this I going to be? Think about it. Yes, JS warriors at the wars are glad to see you. I hope you were there in the initial part too, and if you have missed it, make sure you watch it after the session is over. The moment of inertia, you will have to use rotational motion concept. Say if you take a loop and you take this as your axis, the moment of inertia is mr square. The moment of inertia is mr square, correct? But I don't want that axis. I want basically these axes, this and this diametrical, because it is going to oscillate like this. And I can now use perpendicular axis theorem, and I can say the moment of inertia about either this axis or this axis is I plus I, which is 2I. So therefore I will be mr square by 2. Oh, perfect. Perfect. I got the value of I. So it is nothing but small m r square by 2. What about the other terms? We will think about it also. I is done. Magnetic field is B only. But what about magnetic moment? Magnetic moment is NIA. Don't forget that. Magnetic moment is NIA. Number of turns 1. Current I. Area pi r square. So it is just pi I r square. So what you do is just put over here pi I r square. That's all. That's all. So what you will get the time period as 2 pi root of r square goes, m is there, 2 is there, b is there, I is there. That is what the answer should be. If you want, oh sorry, pi is also there somewhere. Yes, pi is also there. Pi is also there. If you want, you can take that 2 pi also inside. You can also take that 2 pi inside over here, and you can make it in the numerator also. That is also okay. You can just cancel this root 2 and root 2. So it will just become root 2 pi small m divided by IB. Yes, that is what it is. Root of 2 pi m by IB. That is the answer to this question. It has rotational motion concept, torque acting on a dipole concept, magnetic moment concept, and the concept of simple harmonic motion. So this will be a killer question which very few people will be able to solve. But it is going to not just blow your mind, but it is also going to teach you a lot of concepts and revise everything. So expect these kind of variations. So don't just practice very easy questions, practice some higher order questions also. Okay, so that was this, and yep, you'll get the entire PDF in our Telegram channel. Link is there in the description box, and hopefully it will be also updated very soon in our comments or in the description box as well, the link of the PDF. Right, so that was today's session and I'm so glad that you are following up the schedule, you are following up the timetable for this 2-week challenge, and make sure that you complete not just these lectures but also the flash series lectures which were conducted before. If you have further assistance, you want a personal teacher, you want your mentors to be there along with you with test series and assignments, obviously make use of the crash course. It's at a very low price, 999 rupees. Link is there in the description. You want to buy books for your JEE Mains preparation, you can buy the books also. The link is again there in the description. Buy these books at Amazon, physics, chemistry, maths, 46 papers for you to solve, right? All the best. God bless you all. Thank you for liking. Thank you for subscribing. This was your Captain Shreyas signing off. Hasta la vista. Bye bye. Take care. See you again.